A-Level Math P3 complete course. 4-hour complete course. Timeline is in the description. Ready your pen and notebook and get started. Okay. Hello and welcome back. This is A-Level Math P3 course. A-Level Math P3 course. Okay, and in this video we are going to learn each and every topic. We're going to understand. We're going to do some questions. So right now we're going to start with algebra. And in this topic it consists of modulus, binomial expansion, or you can say binomial theorem, polynomial, and partial fractions. Okay, for now let's start with this topic, algebra. Okay, modulus, binomial expansion, partial fraction, algebra, polynomial. Okay, starting with modulus function. Absolute value. The absolute value of a number x denoted as this. The absolute value of a number x denoted as this. This is how you can say that this is known as a modulus. Okay, and modulus means that whenever you put whether the input number is positive or negative, you will always get an output as positive. Okay, let's say if I put plus 3 or minus 3 as an input, then I will get 3 as an output. Okay, so denoted as this is the distance between x and 0 on the number line. The main purpose of modulus is to show the distance regardless of its direction, regardless of its sign, whether it is positive or minus. So yeah, the absolute value of a number x denoted as this modulus is the distance between x and 0 on the number line. Okay, positive 4 and negative 4. If we take the modulus, then it will be known as 4. Yeah, it's the same distance. So this is the purpose of modulus. A modulus function is a function which gives the absolute value of a number or variable. It is a function which gives a positive output irrespective of the input. That means even if the input is negative value of x, there will always be a positive value of y. Okay, this is the equation of the modulus. Y will always be positive whether x is negative or positive. Okay, and you need to see these rules as well. And this one as well. You know that if modulus x less than b, then inside a modulus the input number can be positive x less than b or negative x less than b. Okay, so positive x less than b, or if we put x in here and b in here, then it's going to be minus b greater than x, which means x is greater than minus b. So x less than b and x is greater than minus b, and this is how you made the inequality. And if modulus x is greater than b, then it's the same thing, if x is greater than b, positive x, or negative x greater than b. Okay, and then you know that if x go to the right, b go to the left, so minus b greater than x, so x greater than b. Okay, so these are the two conditions that you need to understand. It's really basic and it's really easy. Question: solve the inequality 9 minus 2x modulus less than 1. So there is the intersection between a modulus and a line, which is y is equals to 1. Okay, so there are two equations. One is y is equals to 9 minus 2x modulus, and y is equals to 1. And if we try to make a substitution, then it's like this: minus 2x is equals to 1, and then we're putting the inequality. So the inequality is this. And since we know that the input could be a negative number or a positive number, so either it is negative, either it is positive. Okay, so minus 9 plus 2x less than 1 plus 9 minus 2x less than 1. Okay, so 9 will go to the right side, so 2x 10, and 2 will go to the right side, 1 will go to the left side, so it's going to be 8 2x. So here it's going to be 5, and in here it's going to be 4. Okay, so these are the answers. Okay, so we have another question. It's the same thing. The input could be a positive or a negative. So 2x minus 1 greater than 9, minus 2x plus 1 greater than 9. If 1 go to the right side, then again 2x less than 10. Again 2x will go to the right, 9 will come to the left, then it's going to be minus 8 2x. So x greater than 5 and minus 4x. Okay, so these are the answers. Okay, now we have another question. Solve the inequality 3 of power x minus 8 less than 0.5. Okay, right here is 3 of power x, and in here we will use the logarithm if you have learned the chapter. If not, don't worry, we will discuss it after this topic. So logarithm, how to deal with this? Let me give you a basic idea what a logarithm is. If 3 of power x is equals to b, then we can say that log 3 is b. Okay, this is what logarithm means, that the opposite side will come here and the base is 3. Okay, let me write it now. Okay, so let's begin. 3. Okay, so we have the question. Solve the inequality 3 of power x minus 8 modulus less than 0.5. Okay, so let's begin. We know that inside a modulus the input could be a positive or negative, so write 3x 0 power x 8 less than 0.5, positive 3 of power x less than 0.5. Okay, so minus 3 of power x minus plus 0.5 plus 3 of power x minus 8 0.5. Then after that we are going to use logarithm, so 7.5 3 of power x and 3 of power x 8.5. Okay, if e of a is equals to 7.5, so it's going to be ln 7.5 e is equals to 7.5, and as for 3x, e b is equals to 3 of x, so it's going to be ln 3 of power x is equals to 3x, so and it's going to be x ln 3 is equals to 3 of power x. Okay, so it means that I can write it down like this and I can write it down like this. So which means, if and since we know that the both base is same, let me write it down first. X ln 3. Since both the bases are same, we can focus on their power level. Okay, so x ln 3 and ln 7.5 upon ln 3x, and we got the value of x as, we got the inequality. Let me use a calculator. Ln 7.5 ln 3, and we got a 1.83 less than x. This is the answer for one of the, we got one value of x. Now we need to find the other. So the same thing that we have done to this one, we're going to do the same thing to this one as well. So it's going to be like, it's going to be like this: e ln x power 3 less than e ln of 8.5. Okay, then we're going to make, we're going to focus on the power since both the base are same. So ln 3 then ln 8.5. Now divide this ln 8.5 by ln 3 and x, and so forth. We're going to use a calculator. Ln 8.5 ln 3, and it's 1.95 as the answer. Okay, congrats. Okay, so now we have this question: solve the inequality x minus 3 less than 3x minus 4. So now right here we have the substitution between the modulus and the line, and so whenever we try to have these kind of situation that there's an intersection between the modulus and the line, so the best way to solve this inequality is to square both sides. We always try to square both sides, so always remember this is rule number 1: square both sides whenever there is intersection between a modulus and the equation of a line. Okay, so square both sides. Okay, so square both sides, and let's just square both sides. Okay, I have squared both sides, and 3 to the 6, 3 to the 9, 3 to the 9 x square, 3 4 the 12, 24, and 4 the 16. Okay, we have this, and then let's simplify it. So 24 will x will go to the right, so 8x square. 6 will go to the right, so it's going to be minus 18x. Okay, and 9 will go to the right, so it's going to be 7. Okay, so we have this equation. Now you need to hold it right here, and you need to observe this equation: 0 less than 8x square minus 18x plus 7. Now think this as, there's you should just think like there's two equation and there's substitution. The first equation is y is equals to 0, and the second equation is y is equals to 8x square minus 18x 7. The first number is positive, denoted as a. It is positive, and if it is positive, then we know then it's going to be a happy smile curve. Okay, and y is equals to 0, so let's say y is equals to 0. Means y is greater than 0. Okay, which means you have this kind of inequality, y is greater than 0, and you just put the y, this equation into here. You just did a substitution. Since y is greater than 0, which means the line is going up, and if the line is going up, then always remember if the line is going up, then the intersection will going toward this sides, and the intersection is going to this sides. Okay, it's getting further and further. The x value, the value of x is, it's getting less and less than x, and greater than x greater than this. Okay, so let's say that and if we try to solve this equation, y is equals to 8x square minus 18x plus 7, then after solving this we will get the values as 7 upon 4, and x is equals to 1 upon 2. So let me write it down here: 1 upon 2, 7 upon 4. Since the value of x is, since it's going this side and this side, it means that x is less than 1 upon 2. Since the value of x is going down, it's decreasing and decreasing, x less than something. And in here the value of x is increasing because, it's getting dissected and this way. So x greater than 7 upon 4. Okay, so we have these two inequalities. And now the last thing that we ever needed to do is to find out that these two inequalities, that which one of these is correct and which one of these is not correct or is wrong, or error, giving an error or something. So now we need to check that which one of these two inequalities is correct. In order to check it, we're going to use dummy values. We're going to take some values which are in the range. So let me just write down the equation first. So we have this x minus 3 modulus less than 3x minus 4. Let's say if I take the value x less than 1 upon 2, let's say if I take 0, and x greater than 7 upon 4, if I take and 7 upon 4 is something like, let's say if I take 2, x greater than 7 upon 2, let's say if I take 2. Okay, so let me check if I put 0. So 0 minus 3 is 4, and 3 less than minus 4. This is wrong. The statement is wrong. Okay, which means this inequality is wrong. If I put this one, then 2 minus 3 to the 6, so it's going to be minus 1, and 3 to the 6 minus 4, 1, 2, and you can say yes, of course 2 is greater than 1, which means this is correct. This inequality is correct, so this is the answer. When dealing with these kind of question, modulus and equation of a line, then we will square both sides. Okay, now let's find the inequality. And there you go, we have found the inequality. Now we need to check. Now we will check that which one of the inequality is correct. Since this is the intersection between modulus and the equation of a line, there is a possibility of 1 or 2 intersection. Take 2 since it is greater than 7 upon 4, and take 0 since it is less than 1 upon 2. Okay, we have checked. We have already know this, and so 7 upon 4 is correct answer. So we have this question: solve the inequality 2x plus 1 modulus less than 3x minus 2 modulus. Okay, so these two are the modulus, and there's an intersection between two modulus. Whenever there's intersection between two modulus, then it gives 100% sure that there's 2-point intersection. Okay, 2-point intersection, it is guaranteed. You don't need to make a verification of inequalities. So 2 points intersection confirmed whenever there's intersection between two modulus. So these are two modulus. Okay, whenever there's intersection between a modulus and a line, then there's a possibility of 1-point intersection. Okay, just like the last time I just solved the question for you, on the previous question. Okay, there was a possibility of 1-point intersection, even though you will get two values of x with inequality. Okay, but then you need to verify that which one of these is correct, and you will get only one answer, which means there's a 1-point intersection, and it was confirmed. Okay, so solve the inequality 2x plus 1 less than 3x minus 2. Two of them are modulus. Let's begin. So 2x plus 1, 3x minus 6. Then square both sides as I just did on the previous question. So square both sides. 4x square plus 4x plus 1 less than. This is a 9x square minus, and 3 to the 6 and 6 is 36. So minus 36. It's going to be minus 36 and plus 36. Okay, x. Okay, and then if we do simplification, if we try to simplify this, then it's going to be 5x square and minus 40x minus 35. Wait, plus 35. Okay, then the same thing. The value 5 is denoted as 8 is positive, so happy smile. Y is 0 greater than y. So y greater than 0, we have the equation y, and y is greater than 0, which means it's going up. Y is greater than 0, and if it's going up, then the value of x will go to the right, value of x will go to the left. So if we try to solve this, then we will find out the value of x. So x is equals to 7, and x is equals to 1. So x is equals to 1, so x is less than 1, and x is greater than 7. Okay, so we have these two values, and these two values are correct, since we know that whenever there's an intersection between two modulus, the 2-point intersection is totally confirmed. Okay, so yeah, this is modulus, and yeah, now let's see the animation, which I just made it for you, just for you to understand it clearly. Let's begin. Okay, now there's an intersection between two modulus. There is a possibility of two intersection only. Okay, square both side. Then we have this. Find the values. Now let's find the inequality. Okay, 5 it's what is this? So happy smile curve, and then y is greater than 0. So yeah, just like this, and there you go, we have got the answer. That was modulus function. This is the end of this part, modulus. Okay, now we are going to move on to binomial expansion. Let's go. Okay, so we have done modulus function, and now we are moving to binomial expansion. Okay, so in the previous course in A-level math B1, we understood what is binomial theorem, and we know that whenever there is an a plus b and power of n, and when n is a positive integer, we know how to expand it. We use the formula that n is a positive integer, and then we know how to expand this. So NCR multiplied by a of n minus r multiplied by b r. This is what we have learned in A-level math B1 course, and now in A-level math B3 we're going to understand how to expand any bracket whenever there is a negative integer, or whenever the value of n is in fraction form, fractions. So these two are totally impossible for you guys. It would look impossible if we try to solve this in a calculator, but there is a trick to how to solve these with these the value of n with negative number and with a fraction form, how to expand these kind of things. So this is what we call this binomial theorem for any index, whether it is positive, negative, or fractions. So let's begin. We will understand the factorial notation, which is a shorthand method to solving problem in arranging of objects. The number of way of arranging an object is n factorial, and this n. Why are we learning this? Actually, it's because factorial is used in binomial, and also this is a chapter A-level math S1 statistic, permutation and combination, so it's quite linked to this. You will understand what is factorial, you will understand what is combination, what is permutation, but for now you need to understand what a factorial is. So factorial, let's say that 5 factorials, what does this means? It means 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 5. Or if I say 4 factorial, that's mean 4 multiplied by 3 multiplied by 2 multiplied by 1. Okay, let's say that 5 factorial, so 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, and I could write it like this as well, that 5 factorial is equals to 5 multiplied by 4 factorial, or 5 factorial multiplied by is equals to 5 multiplied by 4 multiplied by 3 factorial, and so on. Okay, and factorial really means that, for example, let's say that we have 5 different objects, 5 different balls, white ball, blue ball, red ball, pink ball, green ball. They are all different, and in how many ways can we arrange them? How many ways? So we're going to write 5 factorial, and if we try to multiply this, 5 factorial, then it's going to be equal to, let me use a calculator. So then it's going to be equal to 120. So there are 120 ways to arrange these 5 objects in different places. Okay, let's move forward. Yes, just like I told you guys, this is what a factorial is. We also need to understand a short study of combination, because we shall need this concept in evaluating binomial theorem. Just like this formula. The general form of binomial expansion is this. We have been doing the expansion where n is a positive number for which there are a finite number of terms. Now the series can be continued indefinitely when n is a fraction or a negative number. For example, this. What will happen if nc0, nc1, nc2, trying to simplifying this, nc3, here comes nc3, nc4, and so on. We will use the formula, this one. Okay, this is how you solve. The binomial has to be in the form of this, or must be converted to form for this theorem to apply. So we have this formula, and right now you can see here that it must be in this form in order for you to expand any bracket where the power of n is negative number or in fraction forms. Where the power of n is negative or fraction form, you need to put this in this position in order for binomial to work. Okay, in order for binomial theorem to work. And yeah, okay, let's move forward. So now let's do the questions. Expand 1 plus 2x to the power minus 3 in ascending power of x up to including the term x square, simplifying the coefficients. So let's begin. 1 plus 2x to the power minus 3 is equals to nc0 is 1, nc1 is n upon 1 factorial multiplied by 2x of power 1. Then nc2 is n multiplied by n minus 1 2 factorial multiplied by 2x of r square. Okay, now we're going to simplify it. So 1 plus, and yeah, since the value of n is minus 3 multiplied by 2x 1 factorial plus minus 3 multiplied by minus 4 2 factorial multiplied by 4x square. Try to simplify it one more time. 1 minus 3 to the 6, so minus 6x, and 3 for the 12. Okay, 2 ones are 2, 2 2's are 4, 3 for the 12, 12 2's are 24, so it's going to be 24x squared. This is the answer. This is the answer, since it says that you need to find in ascending power of x. This is in ascending power of x of power 0, x of power 1, x of power 2, and then including the term x square. So we have including this term. So this is the answer. Okay, let's see this now. And yeah, this is the answer. Okay, and moving to the next question. Question 2, expand to power 2 plus x square of minus 2 in ascending power of x up to including the term in x of power 4 in simplifying the coefficients. Okay, right now what you're seeing here is, okay, so you have this equation that you need to expand. So what you need to do, you need to simplify in such a manner that the first term should be 1 and then x or something like that. Doesn't matter. The first term must be 1 in order binomial theorem to apply. Okay, so let's do that. Let's put it to one term. Let's force it. Let's change it. So we're going to take 2 as a common, and if we take 2 as a common, then it's going to be like this: 1 plus x square upon 2 minus 2. And now we're going to expand this one. Okay, so let's expand this. So this is going to be 1 upon 4. Now we're going to expand this. nc0 is 1. nc1 is n upon 1 factorial, and then the value of n would be minus 2. So minus 2 upon 1 factorial multiplied by x square upon 2. Okay. Then the second term, nc2 would be n multiplied by n minus 1 upon 2 factorial, and n would be minus 2. So minus 2 multiplied minus 3 upon 2 factorial, and minus 2 multiplied minus 3 would be 6. So 6 upon 2 factorial. 6 upon 2 factorial multiplied by x of power 4 to the 4. Okay, and there you go, we have found the term of x of power 4 right here. Okay, so now we're going to simplify this. So the answer is 1 upon 4. Since this is going to be multiplied to each term, it's going to be multiplied to each term. So 1 upon 4. Okay, 2 ones are 2, 2 ones are 2, so minus 1, and minus 1 upon 4x square. Right here. Okay, let me see. 2 ones are 2, 2 3s are 6. Good. So 1 upon, so it's going to be 3 upon 16, so x of power 4, and this is the answer. Let's see this in here. Yep. And there you go, this is the answer. Question 3. Expand 1 minus 3x of power minus 1 upon 3. Okay, what's amazing about this one? First of all, the power of n is in fraction form, and the second thing that it is in negative. Okay, but it doesn't matter, it's the same thing. In ascending power of x up to including the term in x of power 3, thus the x of power 3 must be included in the term, simplifying the coefficients. Okay, so let's begin. Question, where are you? Okay, 1 minus 3x minus 1 upon 3 is equals to, nc0 is 1, nc0 is 1, plus then nc1 is n upon 1, and the value of n would be minus 1 upon 3. Okay, so minus 1 upon 3, 1 factorial multiplied by minus 3x, and minus 1 upon 3 multiplied by n, the nc2 is n multiplied by n minus 1 upon 2 factorial. So I'm going to use the calculator directly. So first of all, it's going to be minus 1 upon 3 minus 1 upon 3 multiply minus 4 upon 3. So it's 4 upon 9, 4 upon 9, 2 factorial multiply by, and 3 3s are 9, minus 3x square. And then the third would be n multiplied by minus 1 multiplied by minus 2. Okay, so it's going to be minus 1 upon 3 multiplied by minus 1 upon 3 minus 1, which is 4 upon 9, multiplied by minus 1 upon 3 minus 2, 3 factorial of power 3. Okay, now let's simplify it right in here. So 1, it comes 1, then the second term would be also 1, the 3 and 3 is cancelled, so it's going to be plus 1x. Then the second term would be 4 upon 18 multiplied by 9x square, and the fourth term would be, let me use again, minus 28 upon 27 multiplied by, going to be minus 28 upon 27, then it's 3 factorial, and then multiply by 27x cube. Simplify this one more time. 1 plus 1x, 9 for the 36 upon 18 would be 2x square plus 2x square, then minus 28 3x square plus 14 upon 3x cube. This is the answer. Okay, 1 is the first, this is the second, this is the third. Okay, 2x square, and there is an error. This is x 14 upon 3x cube answer. Okay, I've just done a mistake here, but no issue. Another question, expand 4 upon under root 4 minus 3x in ascending power of x up to including the term x square, simplifying the coefficients. Okay, we have this question, expand 4 upon under root 4 minus 3x in ascending power of x up to including the term in x square, simplifying the coefficients. So what we're going to do, okay, first of all let me write it down. 4 multiply 1 upon 4 minus 3x of 1 upon 2. Okay, this is the equation, and right here this 4 needs to be changed to 1 in order for binomial theorem to apply. So let's do that. Let's take the common of 4, and if we take the common of 4, what will happen? 4 multiply 1 upon, taking 4 out, 1 upon 2 multiply by 1 minus 3 upon 4x 1 upon 2, and under root 4 would be 2, and 4 upon 2 would be 2. Okay, so cancel this out, so it's going to be 2. So what we have here is 2 upon, or multiply by 1 minus 3 upon 4x of minus 1 upon 2. Okay, here we go, we have this equation, and now let's do the binomial theorem. Let's try to expand it. Let's expand this. First term would be 1. The second term would be minus 1 upon 2 upon 1 factorial multiply minus 3 upon 4. Then the second term would be n matlab n minus 1 upon 2 factorial. So n is minus 1 upon 2. Then k upon 2 factorial multiply by minus 3 upon 4x squared. Okay, if we try to simplify this even one more, then it's going to be, okay, minus 1 upon 2 multiply minus 3 upon 4, so minus minus is plus, and 4 multiply, and the second term would be 3 upon 8x. First term, second, third term, minus minus plus, and 3 upon, okay, 2 to the 4, so 3 upon 4, 3 upon 4 upon 2 factorial. So it's going to be 3 upon 8. Okay, 3 upon 8 multiply by 3 upon 8 multiply by 9 upon 16 x squared. Okay, simplifying this one more time, 1 plus 3 upon 8x and plus 9 3 that, okay, I'm just going to use a calculator. 3 upon 8 multiplied by 9 upon 16, 27 upon 128 x squared, 27 upon 128 x squared and 2. Okay, now we're going to multiply this by 2, so 2 and 2 multiply 3 upon 8, 2 1 the 2 to 8, so we're going to okay, let me just show you guys. 2 multiplied by 3 upon 8x, 2 1 the 2 to 4 the 8, so 3 upon 4. Okay, so it's this one is going to be 3 upon 4x, then plus 2 multiplied by 27 upon 128 x squared. 64 is the answer. $64. Okay, so 27 on 64 x squared, this is the answer. Okay, congratulations, binomial theorem is done. Now moving to the next one, which is partial fraction. Animation. Okay, as expected, an error in here. This is actually 2. Okay, so 2 plus 3 upon 4x plus 27 upon 64 x squared, this is the answer. Okay, so we have done modulus function, binomial expansion, and now we are going to do partial fraction. Okay, we are going to start with partial fraction. So let's begin. A partial fraction is a decomposition of fraction. It's called partial fraction. A partial fraction, what is a partial fraction? Decomposition of fraction, breaking down into as many parts as possible, is known as partial fraction. Okay, before doing a partial fraction, we need to understand the types of fractions and the types of factors. Okay, so there are types of fraction and types of factor. Let's start with the factors. There are 3 types of factors: linear and non-repeated factors. Okay, linear and repeated factors, and linear and quadratic factors. Linear, which means the x of power 1 is 1, and non-repeated factors, each factor is different. Okay, linear and repeated factors. Linear, x of power 1, and repeated factors, so this is 1 and this is 2 and this is 3. There are 3 factors and 2 of them are repeated. Okay, so these are repeated factors. Linear and quadratic factors. Okay, so we have a linear which is x of power 1 and quadratic which is x of power 2. Here you go, quadratic and linear. So these are types of factors. Okay, if we try to do partial fraction, then we're going to break it down into 3 parts according to the factors. Factor 1, 2, 3, 3 factors, linear, non-repeated factors. So ABC. Linear and repeated factors. There are 3 factors. One is linear and non-repeated, and the other 2 are linear and repeated factors. So 1, 2, and then we're going to put square. Okay, so this is a pattern and how to do partial fraction. You just need to memorize it, or you don't need to memorize this one. This one is easy. So 1, 2, 3, 1, 2, 3. Okay, 1 and 2. Repeated in. So 1, 2, and 3. 1 and 2, 1, 2. You guys must have understood this one, but this one is a little bit tricky. Whenever there's a quadratic factor, ax square plus b, then in here it's going to be bx plus c. Okay, so this is how it is. These are the types of factors. There are 3 types of factors: linear non-repeated factor, linear repeated factors, and linear and quadratic factors. What are the types of fractions? There are 2 types of fraction: improper fraction and proper fractions. So there are 2 types of fractions: proper fraction and improper fraction. This is a proper fraction, 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 but this is not a proper fraction. This is improper fraction, and this is an improper fraction. This is an improper fraction. This is an improper fraction. Okay, that's the difference. So let's say that we have this equation, and now we need to find whether this is a proper fraction or improper fraction. So here's what we're going to do. We're going to see the coefficient of x. We're going to compare it. Let's say 16x minus 16 upon x minus 1, x plus 5, x minus 3. We just need to confirm whether it is a proper or improper fraction. If we try to multiply all of this, and okay, we're only going to observe the coefficient of x. Okay, if we try to multiply all of these, x multiplied by x, x square, x multiplied by x square, to x power cube, and 1 coefficient. We always try to see the coefficient. We always try to see this thing. Okay, so which means if you try to look at it, then it's a proper fraction. We always compare the power of x to see whether it is proper or improper. In this case, it is a proper fraction. What about this one? This is improper fraction because the power of x is same, which means it's improper, and then you get an extra value when decomposing a proper fraction, which is right here. Okay, and that's it. Let's start the questions. Question 1: express this in partial fractions. First of all, we need to find what type of factor it has. If I look at it closely, then this one is quadratic. So this is a linear and quadratic factors. And now what type of fraction it is? If I compare the power of x, 1 upon, and if I multiply this to this and x to the power 3, then yes, this is a proper fraction. Okay, this is a proper fraction. So now let me just solve the equation for you guys. 6 plus 7x 2 minus x 1 plus x square is equals to, since we know that this is a quadratic, linear and quadratic, so a upon 2 minus x plus b x plus c. Okay, now we're going to put this, we're going to cross multiply, like this is an equal sign, this is an equal sign. Okay, so this will go here, and yeah, it's going to multiply to each one. So 6 plus 7x is equals to 2 minus x 1 plus x square multiplied by a upon 2 minus x plus bx plus c 2 minus x 1 plus x square upon 1 plus x square. Okay, cancel out 2 minus x, and cancel out this one and this one. Then what we have here, 6 plus 7x 1 plus x square a plus bx plus c 2 minus x. There you go, we have this now. Now what we're going to do, we're going to put values of x randomly, but it would be best to choose the right one in order to find the unknown values such as a and b and c. A, b, wait, let me choose a different color. A, B, and C. We need to find these unknown values. In order to find this, we're going to put the values. We're going to put the value of x, any number randomly. But it would be I would advise you guys that You need to put the right number. Let's say you need to put the numbers, put the values of x in such a way that you could find the values, these three values. Okay, you need to find the unknown values right here. So you're going to choose the right value of x to find these values ABC. Okay, let's start with, if I say, let's say if I put 0, if I take x is equals to 0, what will happen? B will vanish, and 2 minus 0, so 2 to C, and 1 plus x square. So no, it's not going to work. It's not going to work. It's not going to help me find this. So how should I know that which value of x should I take? The best way to do this is take the factor and put is equal to 0, and then try to find the value of x in this way. So x will go to the right side, so 2 is equal to x. I can put 2. If I put 2 in here, then it's going to be 0, and then all, if I 0 is multiplied by anything, then it's going to be all, everything would go 0. Okay, this one is done. If I put 2, then 2 to the 4, 5a, and yeah, I could find the value of a in this way. If I put 2, I could find the value of a. Okay, then if I put 0, then I could find the value of c, and in this way. Okay, so let's begin. Let's see the animation, and then I'm going to teach you guys. I'm going to explain it throughout the animation. I'm going to. Okay. First, we need to know two things: whether it is proper or improper, which kind of factor it has. Comparing the power of x, this is the proper fraction. The factors are linear and quadratic. Okay. There you go, we have this. Now we will put any value of x to find the unknown ABC variables, but choosing the right value of x will make it easier. Okay. So if we put 2, then we could find the value of a. Okay, we have found the value of a. Now updating it. There you go. If I put 0, then we could find the value of c. Updating it again. There you go. And now what left is b. Putting 1 as a value, and we have found the value of p. And there you go. Partial fraction of this question is done. This is the answer. Question 2. Express this in partial fraction. Okay, so what kind of factor it has? It has linear factors and non-repeated, one thing. And the second thing is, it is a proper fraction. This is a proper fraction because 2 upon 3, right? Okay. The factors are linear and non-repeated. Okay, this way. Again, so you guys, I hope you guys are not confused about, you just need to put this whole thing to here, multiplying to this, whole this. So this one is multiplied to this one, and this one. Okay, and after multiplication, then it would, the common will cancel out to one another. X minus 1 to x minus 1, x minus 2 x minus 2, x plus 1 to x plus 1. Okay, like this. Okay, putting 1 minus 1, get the values, putting 0. So fast. In order to find which value you need to put in the equation, which value of x, put x minus 1 is equal to 0. If then you can put this one, then you can put this one, and you can put this one. Okay, put these values turn by turn, and then find the values of a, b, and c. There you go, and this is the answer. Question 3. Express fx in partial fraction. The factors, okay, comparing this is a proper fraction, of course, and the factors are linear and repeated. Okay, so in this way, again doing the same thing over and over. X plus 1 is equals to 0, so x minus 1, we can put this value of x. Okay, and x minus 3 is equals to 0, so x is equals to 3, we can put this value. If you put 3, then it's going to become 0. If you put 3 here, it's going to become 0. And this one is c actually, but we already found it, and we could find the value of c in this way. Okay. And there you go. Express this in this way. Okay, this one is a improper fraction. Proper fraction. If you look closely, the power of x 3, which means yes, this is an improper fraction. And then we try to see the coefficients. 1 upon 1, and it's 1, so we get an extra value. And the rest of it is the same thing. This was A, this is B, because this is non-linear and this is quadratic Cx plus D. Okay. Since it's improper, it will give an extra value. The factors are linear and quadratic factors. Okay. There you go, we get the answer. Another question, this one is also improper fraction, and comparing the power of x, this is improper fraction, x2 and x of power 2, okay, and then dividing the coefficient, 12 upon 3 is 4, so we get an extra value, okay, x square and x square, and then, okay, we always try to see this, 12x square upon 3x square, 3 1 34 4 is the value, and improper fraction. Since this is improper, it will give an extra value. The factors are linear and non-repeated. Okay. Again, the same thing. Putting the values, get this. Again, putting the values, we get this. Again, putting the values, and then okay, we got the answer. Now the last question. Let me just do this one on my own. Okay. First of all, we need to find whether it is proper or improper. X square is multiplied to x, so x square and x square, 2x square and 2x square. So improper, and also we get an extra value, so it's going to be 1. 1 is the extra value, okay? So 1 plus, since this is the factors are repeated and linear, okay? So B 2x minus 1 plus cx plus, okay, not this one, plus c upon x plus d upon x square. Okay, then we're going to put this value, we're going to be multiplied to each one, just like that. So it will give an extra value. The factors are linear and repeated. Okay, putting the values, we got d. Putting the values, we got b. Putting again the values, we got c, and putting again the value, got d. Okay, this is the answer. Hooray, partial fraction is done. Move on to algebraic polynomial. Okay, we are starting with algebra polynomial. Well, so what is a polynomial? X of power 1, x square, x cube, etc. So if the degree n is an even number, or if a degree n is an odd number, let's say it is even, and let's say it's odd. Okay, so if it is even, how would the graph what would be the graph look like? So the graph would look something like this. If a x square plus b x plus c, where a is positive, the graph would look something like this. Okay, and it will go this way. Both ends of the graph leave the coordinate system at either the top, this is the top, or the bottom. And the graph would look like this if a is equals to, if a is negative. Okay, if a is negative, or you can say minus ax square plus bx plus c. Coefficient of x square is negative, then the graph would look something like this. If the coefficient of x square is positive, the graph would look something like this. And not just for x square, but for x of power 4, x of power 6, x of power 8, all the even numbers of power n would look something like these two. Okay, and also depending on the coefficient. If the coefficient is positive, then looks something like this. If the coefficient is negative, then looks something like this for all of them. Okay, and what about odd? If the equation is an odd number, let's say y is equals to x of power cube, then it would look something like this. Okay, where the n will go in opposite sides. Okay, and if y is equals to minus x cube, then the graph would look something like this. Okay, living on opposite sides. So it also depends, a is, if a is the coefficient of x cube, a is negative, then looks something like this. The coefficient of x square, a is positive, then looks something like this. Okay, this is how it is. This is polynomial. Degree n is an even number. Both ends of the graph leave the coordinate system at either the top or bottom. Okay. If the degree n is an odd number, then the ends of the graph leave the coordinate system at opposite ends. Odd numbers, so leaving the graph at opposite ends. Methods of solving polynomial equations. Synthetic division, comparison method, factor theorem, remainder theorem. Rational root theorem. What is rational root theorem? Law will this method will apply only if the roots are rational and not irrational. Okay. So if the roots are rational, which means p upon q, okay, where q is not equal to 0. So let's say ax cube plus bx plus c is equal to 0. Root theorem RRT. Okay, let's suppose we have this equation x cube minus 8x minus 3 is equal to 0. This one is q, this one is p. Okay, now finding the factors of q, factors of p. Q is 1, p is 3. Finding the factors, the factor of q, the factor of 1 is 1, the factor of 3 is 3 and 1. Now making the possible equations, p upon q is equal to, it could be 1, it could be 1 and 1, it could be 1 and 3, sorry, it could be 3 and 1, could be 3 and 1. Okay, two values that only one of it could be the possible root of the polynomial. Okay, so x is equals to 1, x is equals to 3. Now we need to check it, and in order to check this, that which one of the root is the root of the equation, we're going to use factor theorem. Okay, so factor theorem is basically you put the values of x into the equation, and if it is and if the result is 0, then it's confirmed that that value of x is the root of the equation. Okay, so we have the equation r is equals to 1x cube minus 8x minus 3, where r is known as the remainder. Okay, now if you put the values, let's say 1, if I put the value 1, now I'm using a calculator, or maybe I don't need to use a calculator. 1 minus 8 minus 3, which means it's 10 minus 10. So yeah, this x is equals to 1 is not a root of the equation. So what about 3? Let me use 3 now. Let me use 3. So putting 3. Okay, 27 minus 24 minus 3 and 0 remainder, which means yes, x is equals to 3 is the root of the equation. Hence we have found it the root of the equation, and also means that x minus 3 is a factor of the equation. Okay, this is how you find it out. Now we need to, let's say we need to break down, we need to find more factors of this polynomial equation, x cube minus 8x minus 3. We need to find more of these. We need to break it down into factors. How to do that? In order to find the factors of 1x cube minus 8x minus 3, 0, or y, whatever, we can use synthetic division or comparison method. Any one of them you can choose, and you can find the factors of this equation, but I would recommend using comparison method because in my opinion it's much easier and simpler. But you can do synthetic division as well. Okay, so let's start with synthetic division. First of all, whenever you try to go with synthetic division or comparison method, you always need to have at least one factor of this equation. So the factor is x minus 3, which means x is equals to 3 are one of the roots of the equation, and we need to find other factors, other roots. Okay, I will put 3 here, and x cube, x square, x1, x0. Writing down the coefficient, 1 is the coefficient of x cube, x square of coefficient is 0, x1 coefficient is minus 8, x0, x power 0 coefficient is minus 3. Okay, let's say I put 0. Whenever we try to start synthetic division, we always put 0 to make an addition. Always start with 0, 1, and now 3 will multiply. 3 will try to multiply to this. 3 will multiply it, then come here. So 3 plus 0 is 3. Then again 3 will multiply again, multiplication, and come here. 3 is 9. Minus 8 plus 9 is 1. again 3 will come multiplication and then come in here. So it's going to be 3, and 3 minus 3 and plus 3 is 0. Okay, and this 0 is the remainder. Okay, and finally we have found it another, if you break it down, the cube equation, we got the x square equation, we got the quadratic equation of this. So it's actually 1x square x and this, so plus is equals to 0. No, this is the equation. So what we have here is 1x cube minus 8x minus 3 is equals to x minus 3. Okay, we got this factor, and we got another one, 1x square plus 3x plus 1 plus r, which r is 0. We got the factor and we got the quadratic equation. If you multiply it, then if you multiply these two, then it will come, then this will come, that's the cube, it will come back to the cube equation. Okay, so we have found it through synthetic division, or now I'm going to find it again by comparison method. I'm going to show you guys how to do it. Okay, so let's start with the comparison method. So we have the equation 1x cube minus 8x minus 3 is equals to x minus 3, and I need to find the quadratic I need to find the equation of the quadratic. I need to find the quadratic equation. So x square plus b is equals to, or not is equals to, okay, plus r, and r is the remainder actually. Okay, now we're going to multiply it, we're going to expand this, there's a multiplication between these, and then we try to compare it to one another. 1x cube minus 8x 3 is equals to, x is multiplied to this, multiplied to this, and multiplied to this. Okay, so ax cube plus bx square plus cx, then minus 3 will multiply to each one of them. So minus 3ax square minus 3bx and minus 3c. Okay, now doing the comparison, x cube and x cube, which mean a is equals to 1 minus 8x and cx and bx. So minus 8 is equals to c and minus 3b. Okay, what about 0x square is equals to bx square minus 3x square. So bx square minus 3x square. So 0 is equals to b minus 3, and 3 is equals to b. This is the answer. Now we're going to put in here. Okay, so it's going to be c minus 3 is a 9. 9 will go to the left side, and c is equals to 1. Okay, we got a, we got b, we got c, and there you go, we have found it, the equation. So the equation is 1x square plus 3x plus 1 is the quadratic equation that we wanted to find. Simple as that. So this is how you do comparison method, this is how you do synthetic division, this is how you do factor theorem, and remainder theorem is similar to factor theorem. Okay, let's see it. Okay, therefore the ratio of these divided from this. Okay, we have this example, we have already done it. Let's see the animation. Okay, could be positive and negative. Didn't tell you that. Okay. Substitute each of the number turned into the equation, determine whether it is a root. Okay, the factor. Okay. Now I've just put 3 in here. If I put minus 3 instead of 3, I didn't put minus 3 and I didn't put minus 1. So let me see how it works. If I put minus 3 in 1 minus 3 cube 8 and minus 3, and if I see it, then minus 27 positive 24 minus 3, then it's going to be minus 7, which is incorrect. Okay, so x is equals to 3 is a factor. So whenever we try to do the rational root theorem, we try to make the possible rational roots, which the possible root that could be the roots of the equation. We got, so we got 1 and 3, and it could be either positive 3, negative 3, or positive 1 and negative 1. So these are the possible rational roots. That could be, any one of them could be the roots of the equation. That's what I really meant. This is what RRT is, rational root theorem. Okay, synthetic division and comparison method, just like I told you guys. is the remainder, and we got the equation. Okay, so simplify further, then we got 2 more roots, so there are total 3 roots for this equation. Okay, yes, multiplying x to each one, multiplying minus 3 to each one, expand it, and then try to make a comparison. And now it's time to compare. Comparing to each one of them, getting the values, and putting into the equation. Alright, this is synthetic division, this is comparison method. Remainder theorem. What is the remainder when p was divided by x minus? That the factor theorem and remainder theorem is similar. So we have this equation. If, for example, let's say that that x minus 2 was a factor, could be a factor. If it was a factor, let's suppose that it is a factor, and then if I put the value 2 into the equation and I get px is equal to 0, which means that 0 remainder, then it would be confirmed that x is equals to 2 is the root of the equation, or x minus 2 is a factor. But if it gets something else, then you only have found the value of the remainder. But it also confirmed that this is not a factor and it is not a root. Okay. So now x is equals to 2. Putting into the equation, eight, 16, 14 plus 10. So what I got, I'm using a calculator. At 8 minus 16 minus 14 plus 10, and I got minus 12. So minus 12 is the remainder. Okay. Yes, is the remainder. So this is the remainder theorem. These are the methods of solving polynomial equation. Again, we're going to see more clearly what is comparison method, what is factor theorem, what is remainder theorem. So this is what it is. Dividend. Let's say that I have 6, and this is 18, and if I 6 2s are 12, and I get 6 again. So this is the dividend. No, sorry. This is dividend, something which has been divided. This is the divisor. This is the quotient, and this is the remainder. This is the big picture. This is what it really means. Okay, the equation, and we know that x minus 3 is a factor. We need to factorize it. We have already done this before. So yeah, it's the same thing. Get the values, and we have found the equation of the quadratic. Got the quadratic equation. Now we're going to do the questions. We can use comparison method, or we can use the division. I'm going to use comparison method because I think it's simpler or easier for me. Try to comparing it. We need to find the quotient and the remainder as well, since we know that this is not a factor. Try to comparing it. We got the values. So how did we find the remainder? So 1 is equal to, 1 is equal to this minus 1 c plus r, and we already know the value of c, so minus 2, and we got the value r. Okay, so dividend upon divisor is equals to quotient plus remainder upon divisor. This is something you need to understand and memorize. Is equals to quotient multiplied by divisor and plus remainder. Okay, make a division of divisor, 1 upon d on this side, dividend, and 1 upon d in this side, q multiplied by d plus r. So dividend upon divisor is equals to quotient plus remainder upon divisor. This is how you got it, and you can write it down this way as well. Okay, so this is how it is. Okay, so we have another question. Question this: 5x squared minus 4x plus 1 is divided by x minus 2. Find the quotient and the remainder. Comparison method, again the same thing. 5x squared minus 4x plus 1 is equals to x minus 2 multiplied by x plus 3 plus r. Now it's time to compare. We make the comparison, then we get the values. And here you go. 6x minus 5 is divided by x plus 2. Find the quotient and the remainder. Comparison method. Again the same thing. 6x minus 5 is equal to constant. Multiply x plus 2 plus r. Making the comparison. Finding the values. And there you go. This is the answer. Okay, question. Solve the inequality x cubed plus 5x squared plus 2x minus 8 less than 0. If the roots are rational, then you could easily find the roots by a rational root theorem and then using synthetic division. Okay. If the roots are irrational, then you can find it using a graphic calculator or a scientific calculator. Okay. So these are the roots. This is the graph, making an appropriate diagram, then find the inequality. What is the inequality of when y is less than 0? Okay. So yeah, y is less than 0. Okay, first of all, you're going to break it down into two equations. One is y is less than 0 and the other is the equation which you just make a graph. Y is equals to 0. So y is equals to 0. Y less than 0, so the line is going down. And as it is going down, it's intersecting. It is intersecting, which means it's going here and it's going here. And it's going here. It's going here. It's going here and it's going here. So x less than 1, x greater than minus 2, and x less than minus 4. Okay, there you go. This is the answer. Comparison method. Okay. Question. The polynomial x power of 4 plus 5x plus a is denoted by px. It is given that x squared minus x plus 3 is a factor of px. Find the value of a and factorize px completely. Hence state the number of real roots of the equation px is 0. Justify your answer. Okay. Since we're doing comparison method, multiply x squared to this, multiply by x to this, multiply 3 to this. Now it's time to compare. You compare all of it. You get the values. And there you go. Got the answer. Part 2. Hence state the number of real roots of the equation. There are 2 real roots. Okay, just break it down. Question 2. The polynomial 8x cubed plus ax squared plus px minus 1 where a and b are constant is denoted by px. It is given that x plus 1 is a factor of ps and that when px is divided by 2x plus 1, the remainder is 1. 2. The polynomial 8x cubed plus ax squared plus px minus 1 where a and b are constant is denoted by px. It is given that x plus 1 is a factor of ps and that when px is divided by 2x plus 1, the remainder is 1. Find the values of a and b, and when a and b have this value, factorize px completely. Which means remainder is 0. Put in the values and you got this equation, another one. Putting this and you got another equation. Doing the simultaneous solve and you get this. Part 1 is done, and now part 2. Now we need to factorize using the comparison method. Doing comparison method and you just solved it. Breaking down the quadratic and you get 3 factors. There you go. Question this. The polynomial x of power 5 plus ax of power 4 plus cx of power 3 plus bx of power 2 plus a, where a and b are constant, has a factor this. Find the value of a and b. Okay, so we have this factor. So there are 2. Okay, we have put this and we get the equation. Now since we know that it's a factor, doing comparison method. Substituting to one another. Get this one. You put it in here. Multiply for both sides and you get another equation. You simultaneous solve and you get the answer. There you go. Okay, first one thing for sure that this question is out of it's not really necessary for you guys to have these kind of questions. It was really difficult for me to solve it, especially. It was really difficult for me to solve it. It took me a lot of time to understand this. So don't worry, I just put this equation just so that you could get an idea how to really solve these kind of questions. Okay, so no big deal. You just got it all covered up. Polynomial is it is in your hands. Yeah. So the 4 topics have been done, and I hope that you have understood each and every one of them. Do you have any questions? You can ask me in the comment section below. I will be ready for that. Thank you so much. Now we're going to move to the next topic, and our next topic will be logarithmic and exponential function. So let's begin. Okay, the logarithm tells what the exponent is. And what is the exponent? This is the exponent. This is the opposite number. This is the base. How will you going to find the exponent? Using logarithm. See it carefully. Using the logarithm of any base button. This is the base and this is the opposite number. This is the exponent. This is how you find it. Okay. How do we find the exponent? X is equals to log 2, which is a base, and the opposite number is 8. Then you get 3. This is how you find the exponent. We'll use common logarithm base 10. Log 100. This usually means that the base is really 10. This type of logarithm is written without the base. Okay, see it carefully now. 2x, 2 of power x is equals to 8. Break it down to 2x and break it down to 8 is equals to, let's say, 10. And now you need to make it equal to, a. Now you need to convert this 2 of power x into a 10 of power a. And when finding this exponent a, you will use logarithm 10. Log 10 to x. Okay, you have converted 2 of power x you have converted this to this. Okay, now we're going to do the same thing to 8. So 8 is equals to 10 power b is equals to log 10, and opposite number is 8. Since you have converted this, now you're going to make it equal, since they both were equal. Then, since we know that in O-level math, in Dice's chapter, when both the base are same, then we look at the exponents. So this exponent is equal to this exponent, and this you will learn and you will understand that this x will come to here. Same thing, x log 10 of 2 is equal to log 10 8. Okay, this is equals to log 10 upon log 2, and this is the answer. So 3 is the answer. Now we will use natural logarithm. On a calculator it is ln button. 3 types. First is log. You put in here, you put in here. Second thing is log. I just put in here. This is known as log 10, but no. And the third one is ln, which means log e and this. Okay, so there are 3 types of log. We will use natural logarithm. This is known as natural logarithm. Okay, on a calculator it is ln button. The number e is a mathematical constant. It is the base of the natural logarithm. So this is a natural logarithm. This is how it is. Okay, so what's happening in here? In number 2 you were doing with logarithm, but now in number 3 you're doing the same thing with ln. So you're going to convert this into e of power a, and a, in order to find the exponent a, you will use ln 2x. Okay, the same thing applies in here as well. Then you make it equal, and then you divide it, and x is equal to ln 8 upon ln 2, and it will give the same answer. 3, the same answer. So this is logarithm. Now we're going to do, understand the laws of logarithm. Multiplication. Okay, so multiplication, x, y is equals to x multiplied by y. So we just convert this into this, convert this into this, convert this into this. They all have the same base, and since they have the same base, their exponent will add up. And when they are in multiplication, their exponent will get added up. Okay, we already understand this, that a of power n, or n a multiplied by n b is equals to n a plus b. Okay, they all have the same base. This is how it is. Division, same things. Break it down, z, x, and y, and here z is equals to x upon y. You break it down, z is equals to a log a z. X is equals to a log x, log a and x, and y is equals to a log a y. And since we know that z is equals to x upon y, so we're going to change z into x upon y. Okay, so we're going to change z upon, this is x upon y, and this is x upon y. Okay, and then since we know that whenever there's a division between, let's say, n a in a power upon n of power b, then we know that their power will subtract, and this is exactly what's happening in here. Okay, indices. Okay, any base is acceptable must be same. Okay, so what's happening in here? X and is equals to x 1 multiplied by x 2 multiplied by x 3, and so forth. Yeah, and let's say that you you just convert x upon n this, so into 10 log 10 x upon n. Okay, just put the whole thing this way, 1 1 1 1. Okay, so it's actually 1 2 3, oh sorry just converted this to this. Yeah, 1 1 1 1, just converted this is equal to this. Yeah, then since we know that all the base are the same, so their exponent will get it will get added up. Since there's a multiplication between two base, their exponent will get added up, and so and multiply by log 10x. So this is the main concept. It's telling us that whenever we have a logarithm of any base and we have this kind of a situation, then this n will go to the left side. In here it can go to the left side, which is n multiplied by log power 10 and x. So it's the same thing, and it's really applicable. It's really important to know this stuff, to know this logic. Okay, the logarithm of a number to its own base. Okay, these are small stuff. Some error ln. Okay, need to understand all of this. Okay, simplification condition. Ln x is equal to y, log ab is equal to c. Okay, you have this, x is equal to, you just convert this to this, and then this is equal to this, so x is equal to ey. This is what's explaining this. This is what it means really. Ln x is equals to y. Now look closely. This is x. These are exponents. Okay, and what is the base? The base is obviously e. Log e x is equals to y. Log e, which means it must be like e y. Okay, and x is the opposite, so x. X is the opposite, so x is this one. So x is equals to e of power y. This is what it really means. Yeah, this is what it really means. Okay, same thing for logarithm. Log a b is equals to c, and what is the base? A is the base. Since a is the base, which means a c, and b is the opposite, so b is equals to a of power c. This is what it really means. Okay, good. Now let's start with the questions. If for a of power 8 is equal to 8 of power b, what is the ratio of a to b? Convert it to, guys, to understand this, you can choose any base. Choose any base, whether it is e or 2 or 10. You can choose any base. You can convert it. Choose any base where you wanted to convert it one number to another. Like for example, if this is 4a, I could, if I wanted to, if I am interested, then I could just convert it to in ln, like the base must be e, and then ln 4 of power a. I could convert it to in this way as well, like 10, then log 10 and 4 of power a. I could convert it. I could convert this to 2 log 2 4 of power a. Convert it to any. I could convert it to different ways, but depending on you can choose any base. That's what I'm telling about. That's what I'm telling you guys, that you can choose any base. You can choose e, you can choose 2, you can choose 10, you can choose 5, 4, whatever. But you just need to understand. But the most important thing here is you need to know that whenever you choose the base, then you should also write it down in here as well. E, taking e as a base, and then the opposite number is 8 of power b. Okay, 8 of power b, just like that. Okay, you can choose any base. Here I have chosen e, and it doesn't matter if I choose e. It's not really necessary. And there you go. Let me just solve it for you guys. So ln x of power 4 minus 4 is equals to 4 ln x and ln 4. Okay, this is an exponent, so whenever there's a subtraction, which means the base are being divided to one another. Okay, which means that x power 4 minus 4 is equals to, okay, let me make it simpler first so that you guys could understand it. 4 ln x, which means this is really means x of power 4 minus ln 4. So x of power 4 minus 4 is equals to x of power 4 upon 4. This is what really means, and then 4 will go to the left side, so 4 x of power 4, 4 is 16, is equals to x of power 4, and 16 will go to the right, x of power 4 will go to the left, so it's going to be 3 x of power 4 is equals to 16, and 16 upon 3 under root 4 is equals to x. This is the answer. Very easy. Okay, yeah, there you go. Okay, you just choose positive. If you choose negative, then it will give an error. That's why. Solve the equation. This give you answer correct to 3 decimal places. 5 2x is equals to 5x plus 5 1. Okay, so right now in this question I will use substitution. 5 to multiply by 5x is okay, not like this. 5x multiply by 5x, okay, is equals to 5x and plus 5 1. Using the substitution, 5x is equal to this, so u square u plus 5 and u square minus u minus 5 is equal to 0. Doing the quadratic, this has become the quadratic equation. Then solving this quadratic equation, you will get the roots, and after getting the roots you will reverse the substitution and you get the values of x. Okay, just like here, using the substitution. Now solve it, reverse the substitution, and then using the logarithm, and you get this. Okay, there you go. Another question, solve the equation. This for give you answer correct to 3 significant figures. Okay, break it down, convert it this. Okay, got this one. So it's the same logic, same thing, and you get the answer. Question, solve the equation this, giving you answer correct to 3 decimal places. Let me solve this one, or maybe not, because it's so simple. Same formula, same thing. Okay. Okay, so we have the last question. The variable x and y satisfies the equation this, where n and a are constant. It is given that y is equal to this when x is equal to this, y is equal to this when x is equal to this. Find the values of n and a, giving you answer correct to 2 decimal places. So y of power n is equals to a x of power 3. Okay, now we're going to use the logarithm. Okay, so it is given that y is equal to 2.58 when x is equals to this. Okay, so 2.58 and is equals to a is equals to 1.20 of power 3. Okay, then another one, y is equals to 9.49 is equals to a multiplied by 2.51 of power 3. Now if we substitute this, then a to a, since a is a constant, so 2.58 of power n upon 1.23 is equals to 9.49 of power n upon 2.51 of power 3. Okay, then 2.58 power n upon 9.49 is equals to 1.20 power 3 upon 2.51 power 3. Let's start. Yep, equals, then this one, then this way. Here's what I did. I break it down. 2.58 of power n is equals to e ln 2.58 of power n, which means n will go in here, so n multiply by this, happen to this one, happen to this one, and happen to this one, and then you just do the little bit of calculation and you get the idea. You have founded the value of this. Then you go move on forward. After finding the value of n, you put in here, and y is equals to 1.70 is equal to ax power 3. You again put the values, any values, either this one or this one, doesn't matter. I've chosen this one, and then you get the answer. Okay, this is the answer, and logarithm is finally done. Moving on to the next one, which is trigonometry. Okay, so let's begin. And hello and welcome back. And today in this video we are going to start with trigonometry advanced P3 start. So this is just a recap. I hope you guys have watched A-level math P1 course, because it's the same thing as I'm showing you right now, this animation stuff, sine, cos, tan, what are they, all of this is covered in A-level math P1 course. I hope you will watch that. But now we are moving on, we are going to advanced. So I will just assume that you guys know how to take the angle. I'm just going to assume that you guys know that there are two possible angles, whenever you try to find the angles. So just watch it closely, take a deep breath, and see what it is all about. Okay, the angle theta is known as the base angle or associated acute right angle. For example, this, solve and find the value of theta in the range of this. Sine theta is equal to 1 upon 4 upon 5. Okay, so we will get two possible values, since because this is positive, so sine is positive in here and in here. So sine is equal to theta and sine, minus 1 minus theta. Okay, so these are two possible angles. Again the same thing, so this is negative, which means it will be negative in here and in here. Okay, so theta is equal to 180 minus base angle, and theta is equal to 180 plus base angle. Okay, reciprocals. Okay, so this is new. These are the identities that you need to remember. Cosec for sine, cos for this, that. How to remember this? Cos is for sine, cosec is for sine, sec is for cos, and cot is for tan. As for this one, okay, let's say that we have this identity sine square plus cos square is equals to 1. Divide this all by sine square, and you will get plus cot square and cosec square. Okay, it has been shown here. Then the same thing, divide sine square plus cos square is equals to 1. Divide all of it by cos square. This one cancel out, 1 sine upon cos, so tan square plus 1 is equals to sec square. Okay, as it has been shown here. Sum and difference of angles. Sum and difference of angles. It means that let's say that we have sine and we have two angles A and B, and if we want to expand, or if we want to, whenever we have any two angle, addition of angles or subtraction of angles, we can write it down in this way, like sine A multiplied by cos B plus sine B multiplied by cos A. Okay, and if it is minus, then it will be minus. If it is plus, then it would be plus. As for the cos, the situation is a little bit different. So cos A plus B is equals to cos A multiplied by cos B minus, here it is plus, here it will be minus, and if it is minus, then it will be plus. Okay, cos A multiplied by cos B, sine A multiplied by sine B. Okay, as for the tan A plus B is equals to tan A plus tan B upon 1 minus tan A multiplied by tan B. Okay, this is how it is. If it is a double angle formula, sine, if it has the same, let's say sine 2 multiplied by 45, then sine 2 multiplied by 45, then it's going to be like sine 45 plus 45. So same thing as here, sine 45 cos 45 plus cos 45 sine 45. Okay, or you could just write it down like sine 2a is equals to 2 sine a cos a, cos 2a is equals to cos square a minus sine square a, tan 2a is equals to 2 tan a 1 minus tan a square. Okay, so this is the double angle formula. This is the sum of difference of angles. Actually they are all the same thing, just a little bit, just a different concept about how you look at it. There are difference of angle A and B, and there's same angle, but let's say sine 45 plus 45, then if sine 45 plus 45, then I can write it down as 2 multiplied by sine 45 cos 45. Okay, sine 45 cos 45 plus sine 45 cos 45. So right here you can see here that it's the same thing, and then if you try to add them up, 1 sine 45 cos 45, 1 sine 45 cos 45, then it will come like this will come. Okay, 2 sine 45 cos 45. That's how it is. Yeah, same thing. Okay, so cos 2a is equals to cos square minus sine square, you could just convert it like this: 1 minus sine square minus sine square. So it's going to be like 1 minus 2 sine square. Or you could convert it like this: cos square minus 1 minus cos square, and 2 cos square minus 1. Okay, you can convert it like this and convert it like this. Okay, and it's really um, applicable or very important, this and this. As for this one, sine a, you can just write it down like sine a is equals to sine 1 upon 2a plus 1 upon 2a, and then you can just use this formula: 2 sine 1 upon 2a multiplied by cos 1 upon 2a. Okay, if cos 2a, then cos square minus sine square. If cos 4a, then cos 2a square minus sine 2a square. Okay, if sine 3a plus a, then sine 3a multiplied by cos a plus sine a multiplied by cos 3a. Okay, and that's it. Doing the question now. We have this identity that cos 4 theta minus 4 cos 2 theta plus 3 is equals to 8 sine theta of this. So we need to convert it now. Question: prove the identity cos 4 theta minus 4 cos 2 theta plus 3 is equals to this. So right now we're going to just expand this and okay. So what it really is happening is, cos 4 theta is equals to 2 theta square. And if I try to see this more carefully, then 1 minus 2 sine 2 square theta cos 4 theta. Then 4 sine cos square, which means 1 minus 8 sine square cos square. Then 1 minus 8 sine square, 1 minus sine square, 1 minus 8 sine square plus 8 sine 4. Okay, here you go. This is what exactly right here: 1 minus 8 sine square and plus 8 sine 4. Okay, there you go. We have found this. This is what we really need to do. And as for this one right here, so it's going to be 4 multiplied by cos square minus sine square. So 4 cos square minus 4 sine square plus 3. This is what exactly happening right now. This one right here, cos square. So 4 1 minus s minus 4s square plus 3, and 4 minus 4s square minus 4s square plus 3. Okay, so it's going to be minus and plus, minus and plus, plus, minus 4 and minus plus, so 8 sine square plus 3 minus 4, and yeah, so 4 sine square, 4 sine square, 4 sine square, and minus 4 plus 1, 3, and minus 4, cancel, 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 and we have this answer. Okay, we have this answer. This is the answer. Let's start with this one. Okay, we have this equation. Prove the identity. Sine square matlab cos square is equal to this. Cos 4 theta. Cos 2 theta is cos square minus sine square. Then 1 minus sine square, 1 minus 2 sine square. Okay, cos 2 theta, and then cos 4 theta is equals to 1 minus 2 sine 2 theta square. Okay, then 2 sine 2 theta square, 1 minus cos 4 theta. 2 will go down, sine 2 theta square, and 1 upon 2 1 cos 4 theta. So sine 4 sine cos square is equals to 1 upon 2 1 minus cos 4 theta. 4 will go down, and there you go, we have the answer. This is the R formula. Okay, so what's happening in here? So R, today we're going to discuss about this R formula. A sine theta plus minus b cos theta is equals to a sine theta plus minus base angle. Same thing for this one as well. If you try to expand this, then it will come like this: sine cos plus 1 sine cos. Okay, so this is the R formula, and we have these two equations. These two equations are R formula, and you need to memorize it, or maybe you don't need to memorize it. You just need to understand it. So if you try to expand this one, then it will become like this, and then R is multiplied to this and to this. So R sine cos, R sine cos. Okay, get this. Then what you do is you try to make a comparison between sine theta and sine theta. So A is equals to R cos alpha, and then try to make a comparison between these two. So B is equals to R sine theta. Okay, base angle. So we got these two. If, for example, you need to find the base angle, then you can do something like sine R upon R cos and B upon A. You can find the base angle, this one. Okay, and as for finding the value of R, you can do this: A square plus B square is equals to R. That's it. Same thing. Okay, now we try to make a comparison. Okay, this is how it is. Now we have this question: x squares 4 sin theta minus 3 cos theta in the form this, where this is this, and setting the value of base angle equal to 2 decimal places. Hence solve the equation giving all values of theta such that this. Okay, now you try to make comparison. You got this, then you got this. You find the value of R, and then you can easily find the angle. There you go. Now doing part 2. So what I did is 5 divided by 2, 2 upon 5 sine inverse, and then you try to do, since this is positive, so it's going to be in first quadrant and second quadrant. So first quadrant and second quadrant, second quadrant. Then after that you try to 37 8 times go to the right, 36.7 you go to the right, you get the answers. So this is the answer. Okay, the equation 5 sin x plus 12 cos x is in the form of this, where r is greater than 0 and interval is this. Hence in part 2 solve the equation, give on the solution the interval 0 to 1 dt. So it's the same thing, trying to make a comparison, find the angle. Okay, There you go. Now before going any further, first of all we need to see this interval and this one. We need to change this from this to this. I mean, you're going to change the interval according, in here it is theta only, but in here it is 2 theta, and then there's an addition of 67.38. So we're going to change it in such a manner that 2 theta, so it's going to be 360 degree, and then 2 theta plus 67.38, so this there it would be 67.38 and 360 plus 67.38. okay, so you got a new interval, and then you try to solve this, and then you try to, okay, let me just solve it. So now let me use a calculator, and we got 57.8, 57.8, and we got 122. Okay, so 57.8 is not in the interval, 122 is in this interval, and you need to closely see this interval. Like for example, if it is starting at 67.38, it's going here it's starting from here, it reaches 360, and then it goes along up. So what are the possible angles that could, what are the possibilities that after taking the angle, I mean, how many possible angles are there in this? So there are 3, I guess. In here, since sine is positive, and in here since sine is positive, these 2. So it's going around, so in here 180 minus theta, in here is theta, going around and then coming back again. So look at this interval, yeah, 67.38, and I mean the angle is between 67.38, it is between 67.38, it is between 67.38, and it is less than it is less than 427.4. okay, so starting from here and ending from here, look at here, sine inverse, yeah, sine, if it is sine inverse, then there are 2 possibilities. It could be in the first quadrant and it could be in the second quadrant. Okay, so this is the first quadrant, this is the second quadrant, and we need to also check the interval. Okay, so we know that the angle must be greater than 67.38 and less than 427.4. so one thing for sure, that the base angle is wrong because it is not coming in this interval. Then if we move on, we see the second, in the second quadrant, we see that 180 minus 47.8 is equals to 122. Yes, this is in the interval. And then if we move further and keep on rotating and coming back to first quadrant, then we can see here that yes, that there could be a chance that theta is equal to 360 plus base angle is equals to 8. This could be the possibility of having the angle, having the theta in the first quadrant, and it is in this range. So yeah, this is also correct, so we have the answer. Okay, now let's see here. Okay, we change this interval to this, yes, second, third, fourth, fifth. So we got these 2 answers, got the answer. Okay, yeah, we then try to solve this, and then you get these values. So yeah, this is the answer. Graphs sine. Okay, this is the amplitude. Let's say I have this graph, and so right from here to here is the amplitude, and b, I mean, like for example sine x, so it's going to be one complete wave in 360 degree, and if it is sine 2x, then it's going to be 2 waves in a complete 360 degree, which means 1 wave in a complete 180 degree. Okay, if it is sine 1 upon 2x, then it's going to be like half a wave in a 360 degree, which means 1 wave in 720 degree. So right here, this is sine x, so it's going to be 1 wave in a 360 degree, 180, 0. And c is the y-intercept, going up or down. You can see this graph. This is sine x, and this is cos x. This is cos, and this is sec. Okay, this is tan, and this is cot. That's the difference. So going from 0 to 90, then again 270, and again 360. Okay, and in here it is going like this, 0 to 80, then again going like this, 360. Okay, so this is cot, this is tan, and this is the difference. This is the graph in trigonometry P3. If you are confused about the graph that you have, you haven't seen this before yet, I would recommend you to watch A-level math P1 course. Okay, I've done my work on that. I've discussed it very briefly. I just give you the a brief recap about like y is equals to a sine px plus c. I just give you just a little recap. Okay, but if you want to understand it more accurately, then you can go to A-level math P1 course. Okay, this is P3, this is advanced, so I'll just assume that you have learned P1 course. You have understood P1. Okay, so this is trigonometry P3, and yes, this topic is completed. Now we're going to move to the next one, which is differentiation. Okay, we're going to start differentiation. We're going to see all of these rules on how to differentiate each one and one of them. Okay, this is trig. Imperative implicit differentiation. So let's begin. Starting with number 1, y is equals to e of exponent fx. If we try to differentiate this, then fx will be differentiated, and its derivative will be multiplied to here. Okay. If y is equals to ln fx, if you try to differentiate it, then dy upon dx is equals to 1 upon fx, and then the derivative of fx will be multiplied in here. Okay. The third one is product rule, and the fourth one is quotient rule. I've already discussed this in A-level math P1 course, so I'm not going to discuss in here. It's a waste of time. And as for 5, 6, 7, 8, it's trigonometric differentiation. If y is a sine, then y is a cos. If we differentiate sine, then its derivative is cos. If we differentiate cos, then its derivative is minus sine. Okay. And also you need to see it on the inside. You need to differentiate on the inside as well. You're differentiating sine, and you need to differentiate on the inside. So if you differentiate on the inside, then it's multiplied by a. Okay. Same thing for tan. Differentiate tan, and its derivative is sec square, and multiply by sec. Differentiate sec, and its derivative is sec x tan x. Okay. You need to remember all of these. Then comes this is rule number 9. The first thing that we're going to see is power. Then the second thing is identity, and the third thing is angle. So let's suppose that we have sine fx square, and we need to differentiate this. Okay, so if I try to differentiate this, so the one thing I'm going to see here is the power. The power is 2, so 2 will multiply by this, and then I'm going to see inside its it will be, its derivative would be cos. So right here is sine 5x, then multiplied by cos 5x. Okay, then the next thing is identity, which I've already done this. Then the angle is 5x, so we're going to differentiate this as well, so it's going to be 5. So this is the answer. Okay. Rule number 10, imperative implicit function. So what is implicit function? It means that mixture of y and x, y square, 3x square, y, 2x. We try to differentiate this, and if we differentiate y, then it's going to be 2y, dy upon dx. Differentiate dx square, so it's going to be 6x. Oh, let me write it down. 3x square minus 7y plus 2x. Differentiate y square, 2 will come down, and y will be written dy upon dx. Then 6x minus 7 dy upon dx, and then plus 2. Okay, then you try to take the common of dy upon dx, and then you divide this in here, and you get this equation, and this is the answer. Now derivative of inverse trigonometric function. So what's happening here? Derivative of inverse trigonometric function, tan inverse, differentiate this one. Okay, if you want to differentiate this one, then tan y is equals to x. Then you try to differentiate this, so tan y would be differentiated to sec square y dy upon dx is equals to 1. X will be the x to power 1, and if we try to differentiate this, then it's going to be 1. We have already used the identity. If you differentiate tan, then it will be sec square. Okay, So tan y x over y dy upon dx, and then written like this, and then we use the identity of the trigonometry that 1 plus 10 square is equal to sec square. So 1 plus 10 square, and then we substitute here. So 1 upon 1 plus x square. This is the differentiation of the inverse trigonometry. Okay, question. A curve has equation y is equals to this. Find the x coordinate of the stationary point of the curve in the interval this. We use the quotient rule here. We all know how to use this quotient rule, and then we try to solve this. So using the quotient rule, we know that u upon v is equal to the derivative of u, v minus u, and derivative of v. So u is e of power 3x. This is u, and the derivative of this is e 3x and multiplied by 3. Okay, this is the derivative, as you can see in here. Then we all know what is v. This is v minus e, u is u, and then multiply derivative of v. So we have differentiated tan, and if we differentiate tan, then it's going to be sec 1 upon 2 sec square. Okay, actually sec square 1 upon 2, 1 upon 2 sec square, and then we try to see this this angle and differentiate this. So it's multiplied by 1 upon 2, and then upon this we try to solve this. We know that find the x coordinate of the stationary point of the curve. Stationary point, which means gradient is 0. So we put 0 in here, and then this is multiplied to this, it get vanish. Then we got left with this, but then we take the common of e, it's also vanish. Yeah, it's also get vanish. Then we got this, simplifying it, and 6 we go to the left, and okay, we break it down tan in sine upon cos, and we know that sec is 1 upon cos. Okay, sine upon cos 1 up, this is right here is 1 upon cos square is equals to 6 multiplied by sine upon cos. Cos will go there, get cancelled out, so sine multiplied by cos multiplied by 1 upon 6. Okay. This is exactly what's happening here, and then we will use this identity that sine 1 upon 2 cos 1 upon 2 sine is sine x. Then you try to solve it. This is the answer. Okay, question 2. The equation of a curve is this. Show that do this, then you need to differentiate this and show it like this, and then doing part 2, hence find the exact coordinate of the 2 point of the curve at which the gradient of the normal is 1. We use the product rule in here. This is implicit differentiation. This is the answer. Right here we have just used the product rule. We have used product rule in here. After using the product rule, it's get differentiated. We do all this. So 3xy, okay, 3x 6xy. Since it's already been differentiated, don't need to go any further. Then we simplify things, and then you got this. Then you take the common of 3 minus 3 minus 3, and then you take cancel out, and you got left with this, which is the right one. Then you go into part 2. This was part 1. Gradient of normal 1. Okay. What's happening in here? Hence find the exact coordinate of the 2 point on the curve at which the gradient of the normal is 1. Gradient of the normal is 1. Let's say this is the gradient of normal multiplied by gradient of tangent is equal to minus 1. So the gradient of the normal is 1, and you need to find the gradient of the tangent. So it's going to be minus 1. The gradient of the tangent would be minus 1. So you put minus 1 in here, okay? You just put minus 1. Then you do some solving and simplifying and multiplying, all that stuff. You keep on going. It says that you need to find the exact coordinates of the 2 points. That's why there will be 2 points, 0 is equal to y and 0 is equal to y plus 2x. You try to find the then you put these value back into the equation to find the value of x. Okay, you try to solve this, Hence find the exact coordinate of the 2 point at which the gradient of the normal is 1. So this one is minus 2x is equal to y. Okay, you put this in here, and then you find the value of x for the both. Get this, and okay, just put this in here, and you get this value. So you got the y is equal to 0, you put this in the equation, and you got this. Then after that you got this value, you put this in this equation and you got this, and then back you put in here and you got the value of y. Okay, second equation, the parametric equation of a curve are this: x is equal to 2t plus sine 2t, y is in y is equal to 1 minus 2 cos 2t. Show that dy upon dx is equal to 10t. Right. In here we're going to use the chain rule, okay, like we have discussed already in A-Level Math P1 course, and we all know how to do that. It's so simple, you know, there's nothing more difficult in differentiation. It's really easy if you have already understood how to do it. Okay, so guys, we have used the chain rule here. Dy upon dx is equals to okay, this is how I try to remember this. And then okay, this is the chain rule, and you try to differentiate this, you try to differentiate this, you put it here, you try to solve it, you take the common of 2, then you try to expand this, just so that you could do find this 10 to 10t. 1 minus sine square is equals to cos square. Okay, 2 cos square, this is cancel out, sin upon cos 2, and you got this value. Let's find the x coordinate of the point at which the gradient of the normal is 2. Gradient of the normal 2, so you find the gradient of the tangent and you put it in the equation. Okay, what's happening in here? Hence find the x coordinates of the point on the curve at which the gradient of the normal is 2. First you need to find the gradient of the tangent. After find the tangent, you put in here and then you try to solve this, and since this is negative, it's going to be in the second and in the second quadrant, the fourth quadrant, second and fourth. But then you got this interval which is minus 90 to 90, and you try to solve this, and you can do this one because it is not in this interval, this one is in this interval, and you get this value of t which is negative. Okay, then you put back into this equation, you find the value. After finding the value of t, you put back into the equation, this right here, to find the value of x, since it has asked us for the x coordinate of the point on the curve at which the gradient of the normal is 2. Okay, so this is the answer. Okay, so we have another question. The diagram shows the curve this and one of the maximum point are this. Find the coordinates of m. Okay, so what's happening in here? This is the equation, and first you try to expand this, or if you don't want to expand it, it's fine, but still, if you try to expand this or don't expand this, differentiate this directly, so it's going to be 2 will be multiplied and then x square plus y square, and then you try to differentiate on the inside as well, so it's 2x plus 2y dy upon dx, then 2x okay, so this one is 2x square minus 2y square, then it's going to be 4x minus 4y dy upon dx. Okay, then you just try to simplify stuff, try to yes, of course we need to find this the coordinates of m, and in here you can see that the gradient is 0. If you make a tangent, gradient is 0. That's why we put dy upon dx is equal to 0. If you do that, then get this, so this is 0 0, so yeah, we got this one. Okay, then we try to simplify that and we get this equation. Then we put this equation back into this original one, put in here, and we get 1, and we put in here as well, try to put in here as well. Wait, let's see if I put it, then square is equals to 2, and yes, x square minus 1 minus x square. Okay, so you do this in this way, and then you get the coordinates of x, and then if you just try to if you y square is equals to 1 minus x square, you put this in here, and then you get the coordinates of x, and if you put x square is equals to 1 minus y square, if you put this, then you get the coordinates of y. Okay, happening in here, you got these coordinates, answer is done. Another question, a curve has equation y is equal to 2 upon 3 ln 1 plus 3 cos square x. For this, express dy upon dx in term of tan x. Okay. Complicated. Right here we have this ln bracket 1 plus 3 cos square x. We know how to differentiate this, that the derivative would be this fx would be 1 upon fx multiplied by derivative of fx, and this is what exactly happened in here. If you try what is the derivative of cos square x, 3 cos square x, 3, okay, cos, wait, let's say what is the derivative of cos square. So it's going to be multiplied by 2 cos x multiplied by, then you differentiate on the inside as well, so it's going to be minus sin x, and so multiplying by 3, so it's going to be 6 cos x multiplied by minus sin x, and this is what exactly happened here. Then you go further and going further. Okay, since we need to find dy upon dx in terms of tan x, then we'll force it to become tan x, cos sine upon sine upon cos square. So this one is cancelled, this one is cancelled. So sine upon cos, then it could be 10. Sine square upon cos square, then it would be 10, and 1 upon and 4 upon cos square, so it's going to be 4 sec square. Then we use the identity that sec square is equals to 1 plus tan x square. Okay, we put it in here and we get this value. This is the answer of this topic, differentiation. And yeah, hooray, differentiation P3 is done. Now we're going to move on to integration. So this was okay, so let's start with integration, advanced math P3 integration, and now we're going to understand these rules. Okay, and then we're going to understand the integration of trigonometric functions, sin x, cos x, tan x, x square, sin 2x. Okay, so tan x square, sec x square minus 1, cos x square minus equal to minus cos x, sec x multiplied tan x equals sec x square, cos x multiplied. Okay, right in front of you, you're seeing this, that there are at least 8, 9, 10, 11, 12, 13. There are at least 13, but I'm going to show you 14 and 15 as well, which is 14 would be cot x, doing the integral of cot x. I'm going to show you that, and also I'm going to show you the integral of tan x. Okay, so let's get right to it. And also, yeah, I'm going to show you the integral of sec x. Okay, so there are total 16 of them. Let's start with the first one. The first one is doing the integral of composite function. So let's say that I have ax plus p of power n, and I want to do the integral of this. So what am I going to do? I'm going to add 1 to the power and then divide this by n plus 1. Then I'm going to do I'm going to differentiate inside the brackets, and the derivative will be multiplied by n plus 1, I mean divide by this. Okay, so this is how you do the integration. The derivative would be multiplied by n plus 1 divided by this. Okay, so part 1 is done. In part 2 we have, what we have here is ln fx. Okay, whenever you have whenever you have an equation, or I mean whenever you have an equation and its derivative is up, is in here, then you can, and if you want to integrate this, then it will be ln fx. Okay, for example, let me give you an example. Let's say that I have the derivative 3 upon x 3x plus 1. Okay, the differentiation of 3x plus 1 is 3, which means I can we are doing the integral, right? We are doing integral of this. So the differentiation of 3x plus 1 is 3, and it's right here. So I can write it down like ln 3x plus 1 plus c. This is the answer. This is the integral of this equation. Part number 2 is done. Number 3. So number 3, it says e of power x ax plus b. Just like in differentiation, when we try to differentiate this, ax plus, we try to differentiate this and then you get multiplied by a in differentiation. But now in integration, it's reverse. Okay, instead of multiplying the derivative of this, we're going to divide it by a. Okay, so this is integration, and always remember that integration is the reverse of differentiation. Okay, so number 3 is done, and now we're going to understand about the integration of trigonometric functions. If I try to integrate this, then it would be minus cos x, and if I try to integrate cos x, then it would be minus, if I try to differentiate cos x, then it would be minus sin x. Okay, if I do the integral of cos x, it would be sin x, and if I do the differentiation of sin x, then it would be cos x. The same thing here, and this one is different. Sin 2x dx, and doing the integral. First, look at the identity. It is sine, so doing the integral of sin x, it would be minus cos x. And then seeing the angle, so differentiate this and you get 2, so divided by 2 plus c, and this is the answer. This is the integral. Okay, as for number 8, sin x square, cos x square, tan x square, especially sin x square and cos x square, you cannot integrate this in power form. You need to change it somehow, and then you try to integrate. Just for example, like here, you have changed this into this, and then now it's applicable to integrate this whole equation. So I'm going to change this and by substitution. So cos 2s is equals to sin square minus cos square, it is cos square minus sin square, and then 1 minus sin square minus sin square, and it would be 1 minus 2 sin square. Now we have sin square here, and I'm going to make the subject. Okay, so it would look something like this. Sin square is equals to 1 minus cos 2x upon 2, just like I've shown here. And now I can integrate this, so 1 minus cos 2x upon 2. Break it down, 1 upon 2 minus cos 2x upon 2. Doing the integration, 1 upon 2x minus, okay, first of all, see this identity. This is cos, so doing the integral of cos x would be sin x. So sin 2x upon 2, and then seeing the angle, this is 2x, so if I try to differentiate this, finding the derivative, it would be 2, so divided by 2, 1 upon 2, and this is the answer. So 1 upon 2x minus sin 2x upon 4 plus c, an answer. This is the integration of sin x square, and the same and similar will happen to cos x square. Okay, for tan x square, I will use the identity, which is tan square plus 1 is equals to sec square. If making tan x square the subject, and you get sec square minus 1. Now you try to integrate this, so sec square would be, doing the integration of this would be tan x minus x plus c, and this is the answer. Number 9, cos x square. Okay, I cannot go I don't want to describe this how to integrate this, because you just need to memorize this. Cos x square is equals to minus cot x. It's the same thing, just like it's the same thing like happening to sec x square. Sec x square is doing the integral of sec x square would be tan x, so doing the integral of cos x square would be cot x. Okay, and then if I try to similar, same thing happening. Sec x multiplied tan x, then it would be sec x. Cos x multiplied cot x would be cos x. Okay, so you just need to remember it, and always remember that these two are similar and these two are similar. Okay, now going number 13 would be let's say cot x, doing the integral of cot x. So cot x is cos upon sine, so cos upon sine dx, and now I'm going to use do the substitution. Don't worry about it. For now, I'm going to use substitution to show you how to make the integration, and after that I'm going to teach you guys what is substitution. And after learning that, you can just play back and see how this happened. For now, I'm going to show you guys how to do. I'm just going to show you how to solve this. Okay, so I'm just doing the substitution. Sin x, u is equals to sin x. Then doing the differentiation, du upon dx is equals to sine would be differentiated to cos x. Okay, since now I've found the subject dx. Okay, now I'm going to substitute this in here, and I got cos x upon sin x multiplied by du upon cos x. Cos x is cancelled out. 1 upon sin x multiplied by du. Okay, and it would be, okay, it would be cos x upon u, since I've made the substitution u is equal to sin x. Okay, multiply by du upon cos x. Cancel 1 upon u, and doing the integral, and I got ln u plus c, and ln and u is equals to sine, so sine x plus c is the answer. Ln sine x plus c. Okay, and this is the integral of cot x. 14 is sec x. Doing the integral of sec x. Okay, so sec x. Okay, here's the thing. If I try to integrate this, took a lot of time to make an integration of this sec x. I mean, doing with 1 upon, changing this to 1 upon cos, and then try to do the integration, and it would take a lot of time. So I have a shortcut. I have discovered a shortcut, and that is multiplying it by sec x plus tan x on the denominator and the numerator. Okay, sec x plus tan x, and then doing the substitution, which is u is equals to sec x plus tan x. Now doing the differentiation, and I got sec x tan x plus sec x square. Doing the substitution, sec x square plus tan x sec x upon u multiplied by du upon sec x tan x plus sec x square. Cancelled 1 upon u du. Doing the integral, ln u plus c, and ln u would be sec x plus tan x plus c, and this is the answer for the integral of sec x dx. Okay, number 14 is done. Now we're going to do number 15, and number 15 would be tan x dx. So let's start with this integral. Tan is, obviously you guys know that sine x upon cos x. Okay, doing the substitution, u is equals to cos x, and doing the differentiation, it would be minus sine x. Doing the substitution, sine x upon u multiplied by du upon sine x minus. Cancel 1 upon u, and it would be minus ln u plus c. U is cos x, so ln cos x plus c. Going even further, and it would be ln cos x of power minus 1 plus c, and it would be ln sec s plus c, which is the answer for the integral of tan x dx. Okay, now let's move on. Okay, so now we're going to start with that what are the methods to integration. There are two methods. One is substitution method, and the other is integration by parts. So these are the two methods where you can solve any equations, where you can do integration of any equation. Okay, so these are the two methods that we're going to cover today, starting with substitution method. So in a substitution method, what we do here is, for example, let's say that I have this equation ax plus b of power n multiplied by a. If the derivative of this one is multiplied, and if the derivative of this one is outside, which means it's the derivative of this one, then it is confirmed that you can do substitution. Integration by method of substitution, recall that when using chain rule. So it's connected to chain rule, composite function. It's all about composite function. So this is a composite function, and this its derivative. Then you can easily do substitution. If we have an integral like this, when we have fx and a derivative, then we can easily do substitution. Example like this. Okay, so we have the integral which is his. This is the equation, and we need to do integration. So right here, this one is outside multiplied by 5. So 5 is the derivative of this one, which means you can do substitution. So u is equals to 5x plus 2. Then du upon dx is equals to 5, and then you substitute this, du upon 5 is equals to dx. So dx is replaced by du upon 5. Okay, so it's like this: u power 7 multiply du upon 5, and multiply 5. So 5 is cancelled, and you got left with this. Then you do the integral, and this is the final answer. And since we got u of power 8 upon 8, we know that u is equal to 5x plus 2, so 5x plus 2 of power 8 upon 8. So this is the answer, this is the integral. This is example, this one as well, same thing. The derivative is outside, most likely. 2x upon x square plus 1, x square plus 1 of power minus 1. If we do the derivative, then it would be 2x, which is outside. So yes, you can do substitution. So u is equal to x square plus 1, du upon dx is 2x, du upon 2x dx, do the substitution. Then 2x upon 2x, and yes, 1 upon u. Then you do the integral and ln u, and u is equal to x square plus 1, and this is the answer. Integration by method substitution. Now we're going to do some questions. Okay, so using the substitution, u is equal to 4 minus 3 cos x. So using the substitution, okay, du upon dx, we did the differentiation and we then made the substitution. We're going to change the values. This is really important. Where you apply the limit would also change. Then substituting it, and then after the integration you put the limits and you get the answer. Integration by parts. Recall that when differentiating the product of any two variable, then dy upon dx is this. Now integrate on both sides. So it doesn't matter if you didn't understand all of this, but you just need to remember this formula. Okay, so one thing you need to know that it comes from the product rule. Okay, and then it came this one. Then du upon ds, we went to the left minus, and then it's the same thing. Okay, then you do integration on both sides. Okay, in here, and in here. Okay, this one's cancelled out, and then you decided to do integration on this one. After doing this integration, it becomes v. Integration on this one and integration on this one. Okay, and there you go, you got the formula. Okay, first we need to choose u and v carefully. Choose a u that gets simpler when you differentiate it and a v that doesn't get any more complicated when you integrate it. Late, it goes in this sequence. First one inverse trigonometry, the second logarithm, third is algebraic, the fourth is trigonometric function, and the fifth one is exponential functions. This is how you take it, choose u and v. Now we're going to do some questions. The positive constant a is such that this show that a satisfies the equation. Okay, so we got two things here. One is the algebraic, the second thing is exponential. Okay, so and then we're going to choose u and v. The first comes as algebra, so u, it will be u, and the second one comes late is exponential, which is v. Okay, then we put on the equations. We put it on, we did integral. Okay, so you have put it into the equation. Then you did the integral of v, which is this one. This is v. Okay, and you did differentiation of u and integration of v. Then you do the different integral. You start with this one, the limit. You have done integration and it's right here. Then the integration, and then we're going to apply the limit. Okay, we just took the common x plus 2, and then we applied the limit, and after doing the limit we got this, and then we got this. This is the answer. Okay, another questions, integrate this. Now we're going to choose another. So trigonometry and exponential. Okay, put the values. We did integral. So same thing as I goes up, and this is the answer. Integration of inverse trigonometric function. Okay, what's happening here? Integration of inverse trigonometric function tan inverse. If y is equal to tan inverse, then dy upon dx is 1 upon 1 plus x square. Okay, that's cool. But if then this means that it can go reverse that to tan inverse 1x. Okay, if 1 upon a square plus b square of x square, then 1 upon ab tan inverse bx upon a plus c. So this is the formula. Okay, if 16 and plus 25x square, then then it would be square root, so it would be 4, and square root of 25 would be 5, so 4 multiplied 5, and 5 upon 4x plus c. So this is the answer. Okay, so this is the formula for doing the integration of inverse trigonometric function. Okay, now there's another thing. Trapezium rule, basic form. Yeah. So let's say that we are taking approximate area under the curve. According to the graph, there are 5 intervals between a and b. Yeah. Let's say that I have taken this block, and in this block, this is x1, this is x2, and you put into the equation, you get fx, fx2, fx1. So in order to get this area, use the trapezium rule, which is fx1 plus fx2 upon 2, taking average and multiply by dx. You guys must have known about the what is the formula for the area of a trapezium, that 1 upon 2 multiply by a plus b, and a plus b multiply by h. This is the trapezium rule, and this is what is being applied here. So a plus b is fx1, fx2, and multiply by h, which mean dx. Okay, according to the graph, there are 5 interval between a and b. B minus a upon 5, you get dx, and dx will be same for all trapezium. Okay, dx will be same for all trapezium, and there you go. You make an addition and you get this formula. You make an addition, you get this formula. This is the formula. Okay, this is the first one, this is the last one, and then this is the first one, this is the last one, and then 2 multiplied by fx1, fx2, fx3, fx4. Why it is being multiplied by 2? Because let's start from here, that dx multiplied by fa multiplied by fx1 upon 2, then fx1, there's double fx1, fx1, fx2, fx2, fx3, fx3, fx4, fx4. That's why it has been multiplied by 2. Okay, and this is the formula for finding the area under the curve, approximate area under the curve. This is the trapezium rule, basic form. And then we have this question: use the trapezium rule with 3 intervals to find an approximation to I, giving the answer to occur to 3 decimal places. Let's say that we have this curve and we try to make the approximate area, and there are 3 intervals at least. So we're going to find dx 0.3 divided by 0.3. We make the full chart, then we put the equation, we put the values, and we get the answer. This is trapezium rule, and this was integration. Integration is done. That's it. If you have any question, you can ask me in the comments section below. Thank you so much. And now we're going to move on to the next topic, and the next topic would be differential equations. So let's begin. Hello and welcome back. This is differential. In this video, we are going to learn about what is differential equation. And in differential equation, we will understand what is differential equation. We're going to do some questions, and it's a really easy topic. Let's begin. In our world, things change, and describing how they change often ends up as a differential equation. Differential equations can describe how population change, how heat moves, how spring vibrate, how radioactive material decays, and much more. They are a very natural way to describe many things in the universe. Differential equation is an equation that relates one or more functions and their derivatives. Okay. Question number 1, given that y is equal to 1 when x is equal to 0, solve the differential equation. Dy upon dx is equal to 1 y cube plus 1 upon y square, obtaining an expression for y in terms of x. So let's begin. Dy upon dx is equal to y cube plus 1 upon y square. So on dy we're going to put only y variables only, and on the dx we're going to put, okay, we're going to just put 1 there. Then we're going to integrate on both sides, and then let me show you how. Y square y cube plus 1. You remember that this is multiplied by 1. Okay, so dy is equal to 1 plus dx. Dx will go to the right side, and this whole thing will come to the left side. Okay, then integrate on both sides, and after integrating it, I will get something like this: 1 upon 3 ln y cube plus 1, and I will get x plus c, because 1 will be integrated to x. Okay, then after that I'm going to put the values into the equation, and I will get something like this. I will get this: 1 upon 3 ln 2 is equals to x, is equals to c. I will get this constant. Then after getting the whole equation, I'm going to express this for y in terms of x. So 1 upon 3 ln y cube plus 1 is equals to 1 upon 3 ln 2 plus x, then 1 upon power 3 plus 1 upon 3 ln minus ln to 1 upon 3 is equals to x, and I will get ln 1 2 3 is equals to x, then ex upon 3, then it's going to be y power q plus 1 upon 2 e3x. Okay, let me continue from here. Then it's going to be y cube plus 1 is equals to 2e3x, and under root cube 1 with 2e3x minus 1. This is the answer. Okay, question 1 is done. Moving to question 2. Just see the animation for yourself. Okay, broke it down, do the integration on both sides, then put the values, and then we got c, then expressing y in terms of x. This is the answer. Question 2. In a certain chemical process, a substance is being formed. In t minutes after the start of the process, there are m grams of the substance present. In the process, the rate of increase of m is proportional to f50 minus m square. When t is equal to 0, m is equal to dm upon t, t is equal to 5. Show that m satisfies the differential equation. Okay, right here it says in the process the rate of increase of m is proportional to this, which means m is directly proportional to 50 minus this, and then we will get the constant 50 minus this. Okay, then it says that show that m satisfies the differential equation this, and okay, in the process the rate of increase of m, which means this is dm upon dt, the rate of increase of m is this, proportional to this, so we have this. Now let's see here, k is a constant obviously, so so this thing will come here, okay, and dt will come there, so it's going to be 1 upon 50 minus m square dm, or wait, we need to find the constant first. So now we need to find this constant. Now to find this, we're going to put down the values. Dm upon dt and m is equal to 0. Dm upon dt is 5 is equals to k multiplied by 50 minus 0 square, and then find the value k. 50 upon 5 upon 50, it's 1 upon 500. 1 upon 500, which means it's going to be it's going to be 0.002. So yes, we have this equation, we have satisfied this. So part 1 is done. Part 2, solve the differential equation and show that the solution can be expressed in this form. Now we need to do the differential, we need to solve the convert this into differential equation. So let's do this. Dm upon dt is equals to, okay, so dm upon dt is equals to 1 upon 500 multiplied by 50 minus m square, then 1 upon 50 minus m square dm is equals to 1 upon 500 multiplied by dt. Now we're going to integrate on both sides. Okay, and now if I try to integrate this, then minus m, integrating this, it's going to be 50 minus m of power minus 1 upon minus 1 multiply by, we're going to do differentiation on this inside and then write it down here, so it's going to be minus 1, and so this is the final answer would be 1 upon 50 minus m. This would be the final answer. Okay, is equals to 1 upon 500x plus c. Okay, now if I put the values, okay, so it's not going to be x, it's going to be t plus c. So t is equal to 0 when m is equal to 0, we're going to put down the value, and it's going to be 1 upon 50 minus 0 is equals to 1 upon 500 multiply by 0 plus c, and it's going to be, c is equals to 1 upon 50, c the constant, and put all of this together, and it's going to be, let me write it down in here, it's going to be 1 upon 50 minus m is equals to 1 upon 500t plus 1 upon 50. Okay, and 1 upon 50 minus m is equals to 1 upon 1t plus 1 20 plus 10 upon 500. Get this equation, m is equals to 50 minus 500 upon t plus 10. Okay, we're going to get this equation, and so it is satisfied as well. So part 1 and part 2 is done. Part 3, calculate the mass of the substance when t is equals to 10 and find the time taken for the mass to increase from 0 to 45 grams. Okay, calculate the mass of the substance when t is equal to 10 and find the time taken for the mass to increase from, calculate the mass of the substance when t is equal to 10. We're going to put t is equal to 10 in here, and we will get m is equal to 50 minus 500 upon 20, and if I use a calculator, then it's going to be 25. If t is equals to 10, then m is equals to 25. Okay, this is the answer. And find the time taken for the mass to increase from 0 to 45 grams. Okay, if m is equals to 0, then it's going to be 500 upon 10 plus t 50, and then t 50 plus 500, and t is equals to 0. Okay, and if I put, if m is equals to 45, then 45 is equals to 50 minus 500 and t plus 10, so it's going to be minus 5 minus 500 upon t plus 10, minus minus cancelled, and then it's going to be 5t plus 50, 500, then 5t is equals to 450, and it's going to be 90 seconds. Okay, 90 is the answer. Part 4, so what happened to the mass of the substance as t becomes very large, which means going to positive infinity. If t becomes positive infinity, then m is equals to 50 minus 500 upon infinity. Infinity is equals to 1 upon 0, so it's going to be so m is equals to 50, this is 50, minus 500 upon 1 upon 0, so it's going to be multiplied by 0 upon 1, and m is equals to 5. So 50 gram is the answer if t goes to infinity. Okay, part 1 is done, then part 2 will come. Integrate on both sides, and then putting the value, then you get this constant, and then do the simplification, and part 2 is done. Then part 3, putting the values, you get 25, putting 45 and you get 90, done. 4, putting infinity, then you get 50. Okay, question 2 is done, differential equation, and yeah, it's a very easy topic, wasn't it? And I hope that your concepts are all cleared, and if you want to ask me anything in the comment section, please let me know. And now we're going to move to the next topic, and the next topic would be numerical solution of equation. So let's go and numerical solution of equation. And let's begin. Numerical solution of equation, graph, exponential, and logarithm. This is why this is the exponential, this is the logarithm. Okay, so there are different ways. Okay. Just need to memorize all this. More graphs. Okay. And yeah, that's it. These were the graphs. Numerical solution help us to find the root in any required degree of accuracy and as efficiently as possible. Two methods, sign changing and fixed point iteration. What is a numerical solution? It's another method to find the roots in any required degree of accuracy without using a calculator. Okay, we may use a calculator to find the root, but let's suppose if we don't have any calculator, then we can just do this little trick to find the approximate root in any required degree of accuracy and as efficiently as possible. So there are two methods that we are going to discuss about. The first thing is sign change, and the second thing is fixed point iteration. So the sign change is the equation of the curve crosses the x-axis. Let's say that this graph. Okay, the equation of the curve crosses the x-axis, so fx change sign. So before fx was it was positive, and then it become negative. Since there is this change in sign, then it is confirmed that there is a root there is a root between these interval. Okay, between here and here. Once you have located an interval in which fx change sign, you know that interval must contain a root. This proves that there is a root lying between a and b. Okay. For example, let's see the animation. If fx is equal to x cubed minus 4x plus 5 is equal to, then fx is equal to, then has a root between this, verified by calculation. There is a change in sign, which means it is proved that there is a root between minus 3 and minus 2. Okay, now fixed point iteration. In fixed point iteration, you find a single value or point as your estimate for the value of x. This involves an iterative process, a method of generating a sequence of numbers by continued repetition of the same procedure. If the number obtained in this manner approaches some limiting value, then they are said to converge to this value. Let's say that we have this question 1. If fx is equal to x squared minus x1 minus 2, then fx is equal to 0 have two real roots. Find the approximate value of these roots using iterative process. So there are different ways to make an iterative process, and then make x a subject in 3 different ways. This one. Okay, let x1 is equals to 4. Okay, let's see this one right here. You must have understood that the x, whatever the value you put in x1, the value should be positive. If it be negative, then it will give an error because it's an under root square. Okay, so it doesn't matter that you have to give 4. You could give 3, 2, 1 or 25, any number, any value of x, but it must be positive, approximate root. Okay, you put 4. One thing to know that we will need a scientific calculator to make an iterative process. That's correct. What's happening here? First you put 4. After putting 4, you get 2.45. Then you again put the same thing, and then you get 2.11. Then you put again, and you get 2.02. Then you put again, and then you get 2.01. Now you see this, it's getting closer and closer to the value of 2, which means 2 is the approximate value root of the equation. And if we keep on going, then it will converges to 2, which means 2 is the root of the equation. 2 is the root. Okay, now next one. So if you put 4, we get another one. And now instead of putting each value back to the equation which entire consuming, we can put an answer in the equation using a calculator and keep on pressing is equals to until we get a converged value. In this case, we get x is equals to minus 1 is the root. So we got the 2 roots. But what about the third one? Now this equation is different than the other two. We will need to put in any initial value x, which is in the interval of the 2 root, choosing any value between minus 1 and 2. In this case, we can take x is equal to 1, and we get minus 1, same thing. Okay, so that was a numerical solution. Okay, so that was numerical solution of equation. Now let's see the equation. The sequence of value of given by the iterative formula, this formula, with initial value x1 is equal to 1 converges to this. Use the formula to find this correct two decimal places showing the result of each iteration. State an equation satisfied by this, and hence find the exact value of this. Okay, let's begin. Okay, so yeah, put x1 is equal to 1 into this and this. Then after getting this value, again put this and this. Then after getting this value, you can put this and this. Finally, you get this value, which it converges to this value. So this is the answer. Okay, this is the answer. Okay, so this was part 1, and part 2 is substitute this and you get this value. So in part 2, let's say, okay, so 3 will go to the left side, and 3x minus 2x is equal to this. So you get x and it cancels out, then you got it will actually, so you get x cubed, and then x under root 2 is equal to x. This is the answer. State an equation satisfied by this, and hence find the exact value of this. Okay. Okay, so another question. So we have the equation 99 upon 100 x is equal to sin x. Given that this equation is exactly one root in interval between 0 to 1 upon 2 pi, verify by calculation that this root lies between 0.1 and 0.5. So you put this, values into the equation. You put these values in here. Okay. So after putting it, you will find out that if it is, you'll find out that positive fx and negative fx, and it will be confirmed that there is a root between it. Okay. And as for part 2, use this iterative formula, with initial value x equals 2.5 to find this correctly with 3 test multiplication showing the result of each iteration. Same thing as before. So this is very easy. Okay. So doing part 1. There you go. Change in sign. So we prove that the root lies between 0.1 and 0.5. Part 2. Doing again the same thing, iterative process, and you get this answer. So this is numerical solution of equation. It's the end of numerical solution of equation, and the next topic would be complex number. So let's begin. Complex numbers. This is the topic that we're going to start, and it's a long topic. It got so many things to understand, but don't worry, it's very interesting topic, and we'll cover this right now. Let's begin. Complex numbers. We use the symbol iota to denote the non-real number, like this. You guys must have known that iota is equals to under root minus 1. Then if iota multiplied by iota, then it means that under root minus 1 multiplied by under root minus 1, and it will be minus 1, which means I square is equals to minus 1. Then iota 3, which means I square multiplied by iota 1 multiplied by I. Actually minus 1 multiplied by I, so it's going to be minus iota, and so on. It will go like this, and iota of power 4 is equals to iota square multiplied by I square is equals to minus 1 multiplied by minus 1, so it's going to be 1. So iota of power 4 would be 1, and the same sequence continues over and over again. Okay. It will keep on going like this. Odd numbers would be iota, and even numbers would be minus 1 and 1, minus 1 and 1. Odd number of n leads to sign change of iota. Even number of n leads to sign change of 1. For any positive integer n, if n is a multiple of 4, and iota of power n is equal to 1. If n is not a multiple of 4, iota of n is equal to 4. Evaluate this, divide this by 4, you get this. The question is this. Multiply the question by 4 minus this, you get 3, and then you get this. For any positive integer n, if n is a multiple of 4, then iota of power n is equal to 1. If n is not a multiple of 4, then iota of power n is equal to iota of power r, where r is a remainder when n is divided by 4. Evaluate this. 375 upon 4 is equal to 93.75. The question is 93. 93 multiplied by 4, 372. Then 375 minus 372 is equal to 3. Then iota 3 is obviously iota multiplied by iota multiplied by iota. Iota square multiplied by iota minus 1 iota. So minus I. Numbers. This is the imaginary numbers. This is not an imaginary number. It does not exist in a real number line. Okay. This is the real part and this is the imaginary part, and the whole thing is known as a complex number, and we denote this as z. Okay. Complex number are equal if both real and imaginary parts are equal. Complex number calculations. We have two numbers. Now we're going to do addition, multiplication, subtraction, multiplication, and division of these two numbers. If the real number will add to real number, the imaginary number will add to imaginary number, so we get this. Real number will subtract to real number, imaginary number will subtract to imaginary number, so we get this. Okay, you're going to multiply this, and then you multiply this and this. If you multiply this, then 5 multiplied by 3 plus 2 multiplied by 3. Then 4 iota multiplied by 5, 4 iota multiplied by 2 iota. Complex number a minus b iota is called the conjugate of a plus b iota, which means a minus b iota, a plus b iota are the conjugate of one another. Okay, and if you try to find out the product of these conjugate, then you will get a square plus b square. Okay, you need to remember this. The fact that the product of the complex number and its conjugate is a real number can be used. It can be used to perform division of a complex number. So this is really important. For example, you get this. Now in order to remove iota, okay, for example this, now in order to remove iota in the denominator, multiply both the top and bottom of the fraction by conjugate of the denominator. Okay, which means multiplying this by 4 plus iota and multiply this by 4 plus iota. Multiplying this and the iota and the denominator will vanish. Okay. And there you go, you got this. This is the answer. The conjugate is denoted as C star. Now you got questions. Find the complex number Z satisfying the equations really carefully. 3Z minus I Z star is equal to 1 plus 5I. What is Z? Z is obviously A plus B iota. And what is Z star? Z star is a conjugate of A plus BI, which means A minus BI. Now we're going to put it in the equation, and 3 multiplied by A plus B iota and minus IA minus B iota is equals to 1 plus 5I. Okay, so 3A plus 3B iota minus A iota and plus BI square is equals to 1 plus 5I. So it's going to be 3I 3B iota minus A iota. I square is minus 1, so minus B. Okay, 1 plus 5 iota. Did this happen? Okay, x plus y iota, x minus y iota, then 3x plus cy iota minus x minus y minus x iota minus y is equal to 1 plus 5a. Okay, and then this is the real part and this is the imaginary part. Okay, then you know, if the real part equal to real part, the imaginary part equals to imaginary part. That's why we got two difference equation. So it's actually like this. It's equals to 1 3y minus, okay, let me make it different, minus x plus 3y is equals to 5. We got two different equations. Then we're going to do the substitution either through a calculator or through yourself, and then you get the values of x and y. Okay, and there you go, you got the values. This is the answer. Okay, x is equals to 1, y is equals to 2. Okay, then you found the values of x and y, x plus y iota, so x is 1 plus 2 iota. This is the answer. Okay, it's the same thing as this one before. Okay, again do the substitution, you got these values and you got this. This is the answer. Square root of a complex number. Find the two square root of a complex number. This giving you answer in the form of this, where x and y are real. Two square roots. So you just did the square root is equals to x plus y iota. Then you square both sides. Square both sides to eliminate square roots, and then you're going to expand this. You got this value, and then this is the real part, this is the imaginary part. You make it equal to this, and you can make it equal to this. You got two different equations. Now you will do the, let's see what substitution, and then you get the values. Okay, it also involves quadratic, but don't worry. So we got two values of x. One is in real form and one is in iota form, but since we know that x plus y iota, x is a real number, that's why we're going to choose this one, not this one, because x is real. Okay, so we got two different forms. The answer to our answers. Polynomial equation. It is important to note that if z is equal to a plus by iota is a root of a polynomial, its conjugate complex is this is also a root of the polynomial. When having a complex number, a quadratic equation has two roots which exist in a conjugate pair. A cubic equation has three roots, two of which are conjugate pair. A quadratic equation has four roots that exist either in two conjugate pair or two real root and one conjugate pair. Find the root of the equation, this one. Find the root of the equation 1 plus 2 iota of bracket y w square plus 4w minus this is equals to 0. So that was very fast. So what we have done here, This is A, this is B, and this is C. B for B square minus 4AC upon 2A. Okay. So we have used a quadratic formula. Then we put these values into the equation, and then after doing all of this, we get the values. Okay. Question: the complex number 1 plus 2 iota is denoted by u. It is given that u is the root of the equation 2x cubed minus x squared plus 4x plus 15 equals 0. Find the other two roots of the equation. Since we know that root of a complex number comes in conjugate pair, so first root is this, second root is this. Now we need to find the third root. Okay. So we got this. Then we are using comparison method. And so we got this. Down here we know that the first root is this, but then we know the logic that the roots of complex number comes in conjugate pair. If this is the first root, then this is second root. These are conjugate of one another. So these are two roots, and then we can write it down like this: 1 plus 2 iota. Okay. Multiply by z minus 1 minus 2 iota. Okay. Same thing as we have been doing in quadratic. If we multiply these two, then we get this original equation. Then we use the comparison method. Okay. We use the comparison method, and we got this, the third root. Another question: the polynomial z of power 4 plus cz square plus cz plus 10 pz. The complex number this is denoted by u, showing all your working verify that u is the root of the equation pz is equal to 0. We need to verify that u is the root of the equation when pz is equal to 0. Okay, so we put this into the equation. Okay. Putting it into the equation, we got this. So after putting it into the equation, this is power 2 or power 2. Then multiplying this, then we got this, and after expanding this, then simplifying all of that, and we got this. It is proved. So part 1 is done. Then find the other root of the equation p is equal to 0. Since we know that this is the root, then this will also be the root. Since the roots comes in conjugate pairs, this is the second root. And now we need to find the other second roots. Okay, multiplying the roots, like z is equal to minus 1 plus iota, z is equal to minus 1 minus iota. So z minus plus iota multiply by z minus 1 minus iota. Multiplying this, then we get the equation, and then we use the comparison method, we get the other two roots. Okay, since we know the root of complex number come in conjugate pair, the first root is this, second root is this. Okay, so again the same thing, got this equation. Now using comparison method, it's a long one, but it's fine. And there you go, we have found the equation. Then we do quadratic, and this is it. You use simplify 2 minus 3 iota of power 6 in bracket and shows with a calculator and without the calculator. Let's start with the calculator. If we start with the calculator, and okay, let's suppose that this is the axis, this is the real axis, this is the imaginary axis, and we have 2 minus 3 iota. So 2 minus 3 iota, so it will come in here. Wait, so it's going to be here. Okay, so we have this, and if we try to break it down, then this will be sine iota, this will be cos theta, and this is r. Okay, so we could write it down like this: z is equals to r cos theta plus r sine theta iota, and we could take the common of r and write it down like this. Okay, and yeah. Okay, so right now we can find the value of r using the Pythagoras theorem, which is so r sine theta iota is minus 3 iota, and r cos theta is 2. Okay, so 2 square plus 3 square, and it's going to be 13 under root 13. This is the magnitude of r, and Now we need to find the angle. So tan theta is equals to sin theta upon cos theta. So sin theta is minus 3, but we can take it as like 3 upon 2, and if we take the inverse of tan inverse 3 upon 2, so it's going to be, I'm using a calculator, inverse 3 upon 2, so it's going to be 56.31. So 56.31 degrees. Okay, this is the base angle, but since we know that the tan will be in the, since it is negative, so it's going to be in the second quadrant or fourth quadrant, but right here it's in the fourth quadrant, okay, for tan. So it's going to be 360 minus 56.31 theta, so it's going to be 303.7. you can take this value, or if you want it, you can take minus 56.31 degree. So it's the same thing whether you take this one or this one, it will give the same value. Okay, but let's suppose if I take, let's say I just took this value, so I'm going to put it in the equation, which is z is equals to under root 13 cos minus 56.30 plus sine minus 56.30, and then if I try to make a power of 6 and making a power of 6 cos minus 56.30 plus sine minus 56.36, then it's going to be like, and it's going to be like this, multiply by cos minus 56.30 multiply by 6, okay, and then plus sine minus 56.30 multiply by 6, and so forth, you will get the value. So let's see how it is. Now let's see this. Simplify with a calculator, finding the value of r and then finding the angle, putting to the equation. After putting power 6, you can see here, this is how it will happen whenever we try to, this is how it is, okay. Whenever we put a power 6, it will come down here, it will multiply by its angle, you get this value. And now let's see if we do without a calculator. Doing without a calculator, we can do this like this, multiplication, expanding, and then you will get something like this. It's the same answer. Okay, so this question is done. Third root of unity. The three cube roots of unity can be noted as 1 w square. Find the cube root of 1. So we have 1, since it's one of the roots. How did we find this? Because we know that if we take the cube root of 1, then it's going to be 1. Okay, and now we need to find the other two roots. So doing the comparison method, we can find this quadratic formula, and then we have found the other two roots, which is in iota form. These are the three cube roots of unity and can be denoted as 1 w square. The sum of the three roots of unity is 0. If one complex root of unity is w, the other is 1 upon w. As w is a cube root of unity, w multiplied w square is equal to 1 w cube. The product of the three root of unity is 1 multiplied w square is 1. So the sum of the three root of unity is 1 plus w square is equal to 0. Okay, fine. This is one thing you need to understand. If one complex root of unity is w, the other is 1 upon w. If w is a cube root of unity, w multiplied w square is equal to 1. Okay, so it's saying that w cube is equals to 1. Yeah. The product of the three root of unity is 1 multiplied by w square. Okay, it's the same thing as this one. Is 1 plus w square is equal to 0. The other is w cube is equals to 1. Okay, and the product of three root of unity is 1, because 1 w multiplied w square, which means 1 w cube is equals to 1. 1 multiplied by 1 is equals to 1. Okay, that's why the product of three roots is 1. Go prove that this and this is equals to minus 1. Okay, so what's happening in here? W of minus 32 plus w minus 37 is equal to w of minus 39. Okay, so let's see here. First we took the common, but w minus 39 multiplied by w of power 7 plus w of power 2. If we multiply this and this, then we'll get the same as before. Okay, which means if these two base are multiplying, then their power will be added up, and so it's going to be minus 32. Now in here we just make it more simpler. W is equal to minus 3, and we know that 1 upon, and w of power cube is 1, so 1 upon 1, and so it's going to be 1, and the whole thing disappears. Then we got left with this w power 6 multiplied w32. This again same thing, so it's going to be 1 again, and it will vanish, w power 1 w2, and we know that w power 1 w power 2 and 1 is equal to 0, and then we're going to use this and we get minus 1. Hooray, this is the answer. And this equation is done. Fourth root of unity. Find the fourth root of 1. X of power 4 is equal to 1. So okay, so one thing for sure, that x of power 4 is 1. So x is equals to 1. This is one root. Now we need to find the other three roots. Plus, minus, iota, and minus iota. So these are the four roots. Okay, so it's a different way to do it. The sum of all root is 0. Okay, the product of all root is minus 1. Okay. The complex number can be expressed geometrically using x and y axis renamed as the real axis and imaginary axis respectively. The REIM plane is called the Argand diagram. This is the Argand diagram. Okay. Iota, 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 iota. Multiplying a complex number set by the imaginary number is geometrically equivalent to rotating the point representing C by 90-degree anticlockwise about the origin. If you multiply by iota, it will go 90 degree. We can describe the position of a point by finding the distance r of the line and the angle theta between the line and the x-axis. Okay. Z is equal to x plus yi. Okay. This is the modulus, this is the argument. That's how we call it. Okay. Value is called the modulus, and the theta is known as the argument. Okay, denoted as c this, and denoted as arc z, and its interval is, between 180 and minus 180. Okay, so either it can go this way or it can go this way, but not 360 degree. And r is greater than 0, x square plus y square. Okay, this is known as modulus argument form. Polar coordinates are written in the form r theta. When multiplying two complex numbers in polar form, we will multiply their modulus and add their argument. Okay. Alright. When dividing two complex numbers in polar form, we divide their moduli and subtract their argument. Okay, this is how it is. It's good. Exponential form. Exponential form is similar to modulus argument form. A complex number is said to be in exponential form when it is expressed in the form this, where r is the modulus and theta is the argument. Expressing complex number in the exponential form can help us to multiply or divide two complex numbers more easily. For example, we have this, multiplying two complex numbers. If you multiply two complex numbers, then we can do this. You're multiplying their modulus and then adding up the argument in this way. Dividing two complex number, we can divide this like this. Divide their modulus like this and add and subtract the argument like this. Now we're going to do the question. The complex number this is denoted by this. Express u in the form this, where r is greater than 0. So we have this question. The complex number this is denoted by u, and since it is denoted by u, express u in the form this, where r greater than 0, and we have this interval, hence or otherwise find the modulus and argument of u square and u cube. First of all, we need to denote this as in this form. We can do that. Obviously we can do that. It's so simple. How are we going to do that? We can do this like this, taking modulus like that, taking the argument like this and put in this form, then squaring it. We can find out this, finding the modulus and argument again like this. Okay, and as for the cube, again doing this something like this, and then okay, that's how it is. The complex number 2 plus iota is denoted by u. Express this in the form this by considering the argument, or otherwise prove that this and this. Okay, we have found it this way. Part 2. Okay. First of all, we have just simplified this. Okay, we did some calculations and we got this. Okay, then by considering the argument of this, which means we need to find the angle of this. So tan 4 upon 3, okay, is equal to tan inverse 1 upon 2. So right here, 2 plus iota upon 2 minus iota. So what is telling us is let's say that we have the z is equals to 3, the modulus is equals to 3, and then we know that x plus y iota minus 0 plus 0 iota is equals to 3. Rearrange this and you will get x minus 0 plus y minus 0 iota is equals to 3, the coordinates of the center of the circle. And since we know that the z modulus is equals to under root x square plus y square, then if you put like this, then we will get x minus 0 square plus y minus 0 square is equals to 3, and x minus 0 square plus y minus 0 square is equals to 3 square, and hello, this is the equation of the circle and the coordinates are 0 and 0. Okay, so it starts from the modulus z is equal to 3 and it ended up to the equation of the circle. So this is the center of the coordinate and this is the radius. This is the radius. Okay. Let's say that we have another question which is z minus 2 is equals to 3, and we know that z is x plus y iota minus 2 plus 0 iota is equals to 3. Rearrange this and you will get x minus 2 plus y minus 0 iota is equals to 3, and we know the z modulus is equals to under root x square plus y square, and so it's going to be like x minus 2 square plus y minus 0 square is equals to 3 square, and the coordinates of the center of the circle is 2 and 0. This is the coordinates of the center of the circle, 2 and 0. Okay, and we have this equation z minus 2 z minus 3. We know z is equal to x plus y iota, so x plus y iota minus 2 plus 0 iota is equals to x plus y iota minus 3 plus 0 iota. Okay, now we're going to rearrange this, and so it's going to be x minus 2 plus y minus 0 iota, and I could just do it directly, because we all know this square, it's going to be square is equals to x minus 3 square plus y minus 0 square iota. You can just forget about this iota. Okay, and yeah, and if I try to, I can just cancel out this and this, and I got x and x. If I expand this, then x square minus 4x plus 4 is equals to x square minus 6x plus 9. X square is cancelled out. 6x could go to the right, or yx could go to the 6x could go to the left. Either way, let's say 6x will go to the left. Okay, so it's going to be 2x and it's going to be 5. So it's x is equal to 2.5. Okay. Okay, you can subscribe and reach that since you're already familiar. Okay, and you got this 5.2. So you got the equation of the line. 5.2 was the answer. And 5, since we have found this, which means this is the equation of the line. This is the equation of the line. And this one, doing the same thing as before, and after doing all this, what we're going to get is, okay, so okay, starting from here, we need to simplify this, and after doing some simplification, just like in the completing this way or in the equation of the circle, we came down to this one, and this is the simplest form, where under root 9 upon 4, 3 upon 2 is the radius, and minus 1 upon 2 and y are the coordinates. Okay, so we can write it down back to z minus 1 upon 2 plus y 1. Okay, we can write it down back like this in the simplest form, the equation of the circle. Another one, simplifying this, and Okay, so we got this one. Then we all know what happened here, and simplifying it, then we just, okay, I forgot to put this. Then we all know that it's going to be under root. Then we're going to square both sides, so 2 will be squared to 4, and it's going to be like, it's going to be multiplied to 4x minus this and this, so you got this. Okay, moving on, and you try to simplify things, and you did completing the square in here. Okay, you take the 3 common, you did completing the square. After completing the square, you got the equation of a circle. Okay, the complex number 1 plus iota 3 is denoted by u. Sketch an icon diagram showing the point represent the complex number iota and u. Shade the region whose point represent every complex number set z, satisfying both inequalities. Okay, let's see here then. In here, first it says arc z is greater than arc u. The complex number, the 1 plus iota 3, is denoted by u, and if we try to get the arc of this, and we got this 60 degree, so arc z is greater than 60 degree. Okay, so we got this and 60 degree, so arc z is greater than 60 degree, so it will from anything from here. Then z minus 1 is less than 1. This really means that z minus iota, which means x plus y iota minus 0 plus I iota, and x minus 0 plus y minus y minus 1 iota, which means 0 and 1 are the coordinates of the circle. So 0, x, and 1. So this is 1. This is 1, and it's saying that the radius is 1, and it must be less than 1, which means it must be inside the circle, not the outside. So inside the circle, and the arc z must be greater than 60 degree. So it must be inside of the circle, and so this is the answer. Number u is given by u is equal to 1 plus 2 iota. Part 1. Sketch an arc diagram showing the point represent the complex number u. Show on the same diagram the locus of the complex number. Locus means the circle is known as the locus of the complex number z, such that z minus u is equal to 2, which means the coordinate would be 1 plus 2 iota. It's the same thing, and the radius would be 2. Okay, so it's going to be like this, and 1 and 2 iota 1, we got this, and 2 is the radius, so it's going to be like this. It's going to be like this. Okay, so this is 1 plus 2 iota. This is the center of this is the coordinate of the center. This is the radius. 2 is the radius, and now it's saying find the greatest value of arc z for point on this locus, which means what is the greatest angle from here? What is the greatest angle from here to here? And so let's see this again. So yeah, this is the arc diagram. This is the coordinate of the center of the circle. Okay, we have the circle, and the radius is 2, and now we need to find the angle, the greatest angle. So see it in front of you. Okay, so here's how it happened. First of all, we know that we need to find the greatest angle, so this is the line, from here to here. We need to find the angle, the greatest angle for point on this locus. So first thing, we're just trying to find the angle, iota. So let's make this triangle, and we know that the radius is 2, so 2, and this is 1, and this is 2, this is 1, and this is also 2. So 2 upon 1 sine upon cos is we have found this theta. Then we'll find this another one. So we have this triangle. We know that the radius of the circle is 2, and if we are trying to find this the length, the magnitude of this one, then we know that the coordinate of the center is 1 plus 2 iota. So we can find this using this. We find the magnitude, and this is under root 5, we have found 2 of this, and we need to find this angle, and so the answer is 63.43. 63.43, 63.43, 126.9 is the answer. Okay, it's done. Complex, another question. The complex number this is denoted by this. Find the modulus and argument of u and u square. Part 2, sketch an arc diagram showing the point represent the complex number u and u square. Shade the region whose point represent the complex number z, which satisfy both inequality this and this. Okay, so now we're going to solve this, and okay. So we have this equation 2 upon minus 1 plus iota is denoted by u. So u is equals to this, and now we are solving this, multiplying the conjugate of the denominator to both up and down, top to bottom. We have done this, and then we got this equation. Okay, now we need to find the modulus and argument of this. So this is the modulus and this is the argument. Then the same thing here is we need to find the modulus and argument of this u square. Okay, so modulus is this and the argument is this. So part 1 is done. It was very easy. And part 2, shade, sketch an arc diagram, show the point representing the complex number u and u square. Shade the region whose point represent the complex number z, which satisfy both the inequality modulus less than 2 and this equation as well. So modulus less than 2 and this equation. So we have put the values in this equation, and we just keep on solving this and keep on solving this until we got this. And this is the equation of the line, I think. To do this, and we got this. This is actually the equation of a circle, and this is the equation of a line. Okay, this is the equation of a line, and this is the equation of a circle. And because they are intersecting, so using substitution we have found the coordinates, and these are the coordinates. Okay, one is in here, and the second is in here. And then we have this inequality. So we have this inequality that inside the circle, and this one is saying that this is less than y, which means this. So since it's saying that y is greater than y is greater than this, so the line will go up, and this one is saying that it must be that shading must be done inside the circle, which means it must be less than 2 radius, something like that. So it must be done inside the circle. So this is what we're going to shade, because the line is going up and the radius must be less than 2. So less than 2, it must be done inside the circle. So this is the answer. Okay, the complex number this is denoted by this. Sketch an arc diagram showing the point representing u. Shade the region whose point represent the complex number z, satisfy both inequalities. Okay, so what we have here is the equation of a line. This is the equation of a line, and we need to find the angle as well. So we got this angle, and okay, this was the equation of the line. You simplify this and you got this, x less than 1. Okay, x is greater than 1, sorry, x is greater than 1, so it's going this side. And we have this inequality, z arc z minus u is this. So finding this and starting from here, the angle must be between 1 upon 4 pi to 0. So 1 upon 4 pi, and so this is the shading part. Okay, so this is the answer. Another one, the complex number u is defined by this, where the constant a is real. Express u in the form this, where x and y are real. Find the value of a for which we're going to simplify this. Okay, so what's happening here, so we have this, and then you simplify it and you got this equation where a constant a is real. So this is constant a. Express u in the form this, we have found it. And then doing part 2, find the value of a for which arc this. Conjugate is equal to 3 upon 4 pi. So what would be the conjugate of this? The conjugate of this would be plus positive, and then we're going to this is x, this is y, so y upon x. 10 is equals to 10 is equals to y upon x. So it's going to be 10 iota upon a square plus 4 upon 5a upon a square plus 4. Cancel, you got 10 upon 5a. So you got 10 upon 5a is equals to 3 upon 4. And so this is how it is. Okay. Another question, the complex number u is defined by u is equal to 6 minus 3 iota upon 1 plus 2 iota. For complex set satisfying this, find the least possible value of z. Okay, we have simplifying this. We put this in this. We know that this is find the least possible value of z. Okay, so this is how you find it. That find the least possible value of z modulus. Find the least 3, and this is 1 upon 4 pi. So doing all this calculation, we can find the z modulus, and we have found this value. Part 2, for complex number z satisfying this, find the greatest possible value of this. Find the greatest possible value of this. Okay, so 1 plus I, then simplify, then this is the coordinates. This is the equation of a circle actually, and since we have found the equation of a circle, and then it's saying that find the greatest possible value of z. So this is the greatest possible value. We know this is 3, and this is 3, and then we found this. This is 1, since 1 is a radius, so this is the answer. We have another question. This, on a sketch of an arc diagram, state the region whose point represents the complex number z which satisfies both inequalities. This is the equation of a circle, and this, okay, z plus 2, which means z plus 2, so x plus y iota minus 2 plus 0 iota. So it's going to be 2 plus 0 is a point where you're going to start it, make it a line, then 1 upon 4 pi. Now calculate the greatest value of this for point the ratio given you answer to the decimal places. So let's see what happens. Okay, so we have the equation of a circle and the angle. Drawing the equation of a circle, I guess, or not. Okay, so we have this and we have this. There you go. Now calculate the greatest value of z for point on this region. Okay. Okay, so what's happening in here? So we have this equation of a circle, we simplify this and we got this equation. Then as for this one, 2. So this is the equation of a line. Doing the simultaneous solve, and we can find the points of this one. Got the point of this one. So the points were, these were the points y and x, and then doing Pythagoras theorem, you got this. This is the answer. Okay. On an arc diagram, sketch the locus representing complex number z satisfying this, the equation of a circle, and the locus representing complex number w satisfying this. Find the least value of z minus w for point on this loci. Okay, complex number. We got the equation of a circle and we got the angle. Putting this and this. Now we need to find the least value of z minus w. Okay, so it's saying that z minus w. Let me write it down. Z minus w. Z is the circle. W is the line, and it's saying find the least value of z minus w, which means what is find the least distance between these two. Okay, which means it's saying that this and this is the distance that we need to find. So we can start it by doing that what is the distance between this. Then it becomes perpendicular, because obviously let's say that this is the point, this is the line. What is the least distance between these two? We draw a straight line and it becomes a perpendicular. So this is the least distance between the point and a line. So same thing applies in here, that this is the point and this is the line. The least distance is this, and it becomes perpendicular, and this become a complete right angle triangle. Okay, so now we're going to convert this thing into a line, and after finding the line, we will find out this point. Then we could find this angle as well. Then using sine, we can find this length. Okay, so this is 1 upon 4. Now it becomes z. so it becomes 1 upon 4 as well. Then we got this line, and if x is equal to 2, then y is equal to 2. So we know that this whole thing is 3 upon 4 pi, but we know that if we take this, then this would be pi upon 2. Pi upon 2. So 3 upon 4 pi minus pi upon 2 would be 1 upon 4 pi. So we have 1 upon 4 5. And then since 1 upon 4 5, and since this is becoming a complete z, then this angle will be same in this angle as well. Okay, now after converting this into a line, an equation of a line, we get this. And if x is equal to 0, then y is equal to 2, which means right here is 2. And since we know that this is 1, the radius is 1, so 1 plus 2 is 3. From here to here it is 3. We got this angle, and now we can use a sine to find this one, p. Okay, so we have found it now. And since we know that the radius of this circle is 1, so 3 under root 2 upon 2 minus 1 is the answer for finding the least distance between the equation of a circle and the line. Okay, so there you go. This is how you do it, and congratulations, this is complex number is done. And now we are moving on to vector 3D. Okay, so now we are going to start 3D vector. This is the last topic of A-level Math B3. Let's begin. This is the vector in 3D dimension x, y, z, x-axis, y-axis, z-axis. Let's say we have the vector OA and OB. This is OA and this is OB in here. So we have these coordinates. This x coordinate, y coordinate, and z coordinates. OA is equals to x, y, z 1, 2, 3, which means first it went to x1, it went to, in the x-axis it went 1 unit, 1, then in the y-axis it goes 2 units, 2, and then in the z-axis it goes 3 units, 3. So this is OA. Okay, and as for OB, x, y, z, OB went to 2 units in the x-axis, then 2 units on the y-axis, and then 5 units on the z-axis. And so we got OB 2, 2, 5. Any vector that starts from the origin is known as a position vector because it is starting from the origin. We can find the magnitude of each vector as follows using the Pythagoras theorem. Okay, this is how you find the magnitude. Another vector OC, BC is equals to BO plus OC. We must have, you guys must have done in O-level math. I mean, it's so simple about the addition of vectors and subtraction of vectors. In addition of vectors, where BC is equals to BO plus OC. So this one, these two must be same. It must be same in order for addition to occur. Must be same. Okay. So BC is equals to BO plus OC. BO, since instead of OB it's BO, which means BO is equals to minus OB. Okay, it will change direction, so change in the sign will change as well. So minus 2 minus 2 minus 5. And as for OC, it's the same thing, and we got this BC. So what is BC? It means that going from B to C. Look here, it's going from B to C. I mean, it's going from B to C. This is BC. These are the coordinates. It's saying that going 1 at x-axis, and obviously the way I've drawn this, this graph is not really authentic, but still, this is the coordinate from going B to C. Okay. Going from B to C with a given coordinate, this type of vector is known as direction vector. Okay, this is how it is. You can see here, going from 1 at the x-axis 1, then 3 on this y and on the y-axis, and then down minus 1. Going from B to C is known as direction vector. BC is equals to 1, 3 minus 1. Okay. A vector of magnitude 1 is called a unit vector. The unit vector in the position direction of x, y, z are labeled as I, j, k. Let's say we have a vector this. What is the unit vector of this? This is how you find the unit vector. So a unit vector in the position direction of x, y, z are labeled as I hat, j hat, and k hat. Okay, And what is the unit vector of this? Yeah, the unit vector of, and the unit vector is denoted as OA hat. Okay, this is the unit vector. Okay, so whenever you need to find the unit vectors, then the vector of OA upon the magnitude of OA, and then you get this unit vector. And if you take the magnitude of the unit vector, it will be equal to 1. Okay, so let's move on. The scalar product or dot product of vector p and q is the number of scalar where theta is the angle between direction of p and q. It is written p dot q, pronouns p dot q. So this is the dot product, and the main purpose of using the dot product is to find the angle between the two, just to know whether the two vectors are perpendicular or parallel. The dot product has two advantages: to find the angle and to confirm whether any vectors such as p and q are perpendicular or not. This is perpendicular, so cos 90 is 0, so p dot q is equal to 0, which means these two vectors are perpendicular. Okay, so there are two things to understand. So that whenever it is being asked about the angle between the direction of a and b, so there are two things. One is angle between two vectors, or angle between two vector lines. Okay, if I'm talking about angle between two vectors, then what I really mean is that finding the angle between a and b vectors. And if I'm talking about angle between two vector lines, then what I really mean is the angle between two vector lines. Okay, that's number one that you need to understand, between the difference between two things, two vectors and two vector lines. Okay, second thing is that whenever you have been asked to find the angle, you always need to remember that the angle must not exceed 180 degree. Okay, it must not exceed 180 degree. So it applies for these two. The angle must not exceed 180 degree. Third thing is that if you have been asked to find the acute angle, find the acute angle, then it would be about this one, the angle between two vector lines. First you find the angle, and then you subtract it to, you subtract 180 to that angle to find the acute angle. Okay, and you will always be asked about the acute angle when trying to find the angle between two vector lines. Okay, so there are two possibilities when for angle whenever you're trying to find the angle between two vector lines. First, the obtuse angle, which you if it has been asked, if the question asks you to find the angle, it's written the angle between direction a and b. And let's suppose that the vectors are vector lines. You have been given the direction vector of the vector lines, and you have been asked the angle. It's simply written the angle between the direction of a and b. Then it really means that you have calculated the obtuse angle. Okay, angle greater than 90. But if you have been asked to find the acute angle, between the direction a and b, then what you will do, you will subtract this to 180 minus obtuse angle to find acute angle. That's it. This is what I really wanted to tell you guys, the difference between two vectors and two vector lines. As for the two vectors, if it has asked you about to find the angle between two vectors, then simply go with it. But always remember that the angle must not exceed 180 degree. Okay, so let's begin. So right now in front of you, let's suppose that it's all about two vector lines. Okay, we'll use the dot product. So the dot product is a dot b is equals to magnitude of a multiply magnitude of b multiply cos theta. A dot b is 2, 3 and 2. I mean, a is 2 minus 2 1 and b is 2 6 3. Okay, so 2 will be multiplied to 2, so 2 multiplied by 2, then minus 2 multiplied to 6, minus 2 multiplied by 6, 1 is multiplied to 3, 1 is multiplied by 2, 3 is equals to the magnitude of a is 2 square plus 2 square 1 square, so it's going to be 20 to the 4 to the 4 4 8 1 9. So the square root of 9 is 3 multiplied by 2 to the 4 6 6 36 and 3 is a 9. So it's going to be let me use a calculator. 2 square plus 6 square plus 3 square, and it's going to be 49, and under square root of 49 is 7 multiplied by cos theta. Okay, so 4 minus 12 and plus 3 is minus 5 upon 21 is equals to cos theta. Now right here it says find the angle between the direction A and B, and we know that this is negative, so it's going to be the two possible values would be here and here. But since I've already talked about this, that the angle must not exceed 180 degrees, so it's not going to be this, it's going to be this. Okay, so 180 minus base angle. So first of all we're going to find the base angle. So 5 upon 21, I mean cos inverse 5 upon 21, it's going to be 76.22. And if I find the angle, then 180 minus this, then it's going to be 104 if I round it up. So this is the answer for part 1. And as for part 2, the value of P for which B and C are perpendicular. If B and C are perpendicular, then this whole thing, then cos 90 is equals to 0. So the dot product will be 0, and what would be left is part 2 is, B and C. So B and C. 263 dot P plus 1 dot 0, and then I do the calculation and I find the value of Q. Okay, so let's now finding the base angle. Okay, you need to see this animation is all about the finding the angle between two vector lines. Okay, so there are always two possible values, the acute angle and the obtuse angle. If you have been asked to find the acute angle, then base angle is the answer, correct? Or if you wanted to do this with logic, then you could just find the obtuse angle, and then 180 minus obtuse angle is equals to acute angle. Okay, or you could just use the base angle as the acute angle. It's the same thing. If you have been asked that to find the angle and angle less, then it's the answer. Yes. So right here we have found the angle. Now part 2, 0, and then doing the calculation, and you got the value of P. This is the answer. Okay, good luck. Now question this: the straight line L pass through the point A and B whose position vectors are this and this. The plane B has equation this: given that L intersect P, find the position vector of the point of intersection. The straight line L, you need to understand how to find the equation of a line. And also you need to understand how to find the equation of a plane. This is the line, this is the line, and this is the plane. Okay, you need to understand how to find the equation of a plane. The equation of a plane could be written as, it's more like by plus cz is equals to d. This is how you write the equation of a plane. And as for the equation of a line, it's going to be written as, let's say, lambda is equals to x y c plus and r 3 5 1. Okay, this would be the position vector 1 3 5. There will be values, actually there will be values. This would be the position vector, and this would be the direction vector. Always remember that if you have been given two position vectors, you can make a direction vector, and then you can choose any one of the position vector, and there you go, you have the equation of a line. The straight line L passes the points A and B whose position vectors are this and this. So find the direction vector of A and B. AB, this is the direction vector, and then choose any position vector, either A or B, doesn't matter. So it's like this: A OA plus R AB. So this is the equation of a line. This is how you make the equation of a line. Okay, these are the position vectors. In order to make a line, first take any position vector and also make the direction vector. So you have make this direction vector, and there you go. This is the direction vector of any 2 points such as A and B. Take the position vector of either A or B, and in this case A is chosen. This is a scalar. The equation of a plane is this. Now you're going to put the values in it. Put the values, and you get the lambda value. Then you put this again, and you found it the intersection points. Because there is an intersection between a line and a curve. Okay, it's not in 3D form, so I hope you won't get confused by my graph. The plane P is this, given that L intersects P. It's intersect P like in a 3D. Boom. Breeze through it. Find the position vector of point of intersection. So this is what I'm actually doing. Position vector. This is the intersection of points. Okay, the equation of a plane. We will always require 3 points, position vector or 2 direction vector whenever we need to find the equation of the plane. These are the 3 points A, B, C. Position vectors. So we have 3 points position vectors. Now we need to make 2 direction vectors such as AB and AC and do the cross product in order to find the normal end of the plane, which is also the direction vector. Okay, so we have made the direction vectors. Now we use the cross product to find the third direction vector, which is the perpendicular to both AB and AC. This is the benefit of cross product. We can either use through matrix, or there's lots of techniques in order to find the cross product, in order to do the cross product. This is one of them, and I think it's the most easy one. So you got the direction vector. Now we have the equation of plane. Okay, x, y, z. Then you got these. Is this choosing any position vector, OA, OB, or OC? Good. Okay. Here's the thing. R dot n is equals to A dot n. N is a normal position vector. Multiplying this, you will get a constant. Okay. And yeah, OA is a position vector. You can put any one of them, OA, OC, OB. It will give the same answer. Okay. And you got the equation of a plane, and this is the plane. Okay. Denoted as D is a constant scale. It gives the location of the plane. If you change the value of D, it will move back and forth perpendicular to normal. So this is all about the equation of a plane. The plane P has equation this, and we have the equation of a line. Find the equation of the plane which contains L and is perpendicular to P, giving you answer in the form of AX plus BY plus CZ is equal to 1. Okay. So L contains this and this another plane that we need to find. We can use a cross product to find the normal of that plane, and then you can easily find the equation. So we got the normal, and you put the equation in it. And there you go, we have the equation. Another question, the point P has position vector this. So we have the equation, the point P has position vector this. Show that the perpendicular distance from P to the line K is equal to this. And we have the equation of a line. Show that the perpendicular distance from P to the line K is equal to this. Okay, so this is a line and this is P, and we need to find the perpendicular distance. Okay, so this is a line, this is a P. We got this, and then finding NP. Then using a dot product of the direction vector of line and NP, and we can easily find the values. Got lambda and put back, and you got the. Okay, what you got is, you put the lambda, you put the value back into this, and that you get NP. Okay, then you do the Pythagoras theorem. You find the magnitude of this, and there you go. This is the answer. This is the distance, perpendicular distance between P and N. Another question, the line K and M have vector properties, vector equations, this and this respectively. Show that K and M intersect and find the position vector of their point of intersection. First of all, we need to show that they intersect, and then we need to find the position vector of their point of intersection. Make it equal. If the line intersects, then it must have same coordinate x, y, z of the point. Do simultaneous solve. Got these, put these in this, the third one, and then yeah, it's proof that they have intersected, and now we need to find the position vector. Now to find the coordinate of the position of intersection. Putting the values either in line K or in line M will give the coordinate of the point of intersection. Okay, let's choose line K. You can choose line L as well. It doesn't. Line M. It doesn't matter. It will give the same answer. This is the coordinate of the point of intersection. So part 1 is done. Now let's move on to part 2. Find the equation of the plane containing K and M, giving you answer in the form of this. So we will use the cross product because they contain this, and the normal end is perpendicular to both M and K. This is the only way. Whenever you need to find the equation of a plane, you always use a cross product to find the normal, and the normal is always perpendicular to the direction vector M and K, perpendicular. Okay, you will take the intersection point of as position vector. Okay, and this is the answer. Moving on to another question, the straight line K passed through the point A and B with position vectors this and this. Respectively, the line intersects the plane with equation this at the point C. Find the position vector of C. Saying that the straight line K passed through the point A and B, and then the line intersects the plane P with equation this at the point C. So first thing here that we have this position vectors, we will make the equation of a line, and then we know how to find the intersection point between a plane and a line. Okay, so we will find the intersection point C as well. Then after that, find the acute angle between K and P, between a line and P. Okay, that's a new thing for you. And show that the perpendicular distance between from A to P is equal to 2. From A to P, perpendicular distance from A to P, which means between a point and a plane, the distance must be 2. It must be 2. First of all, we are going to make the equation of a line, just like we have done it before. Making the direction vector and then taking the direction vector and choosing any position vector. We have the equation of the line. Now we're going to put this into the equation of the plane. We will find the value of the lambda, then put back into the same thing, and you will get the coordinates of the point of intersection. This is point C. Part 1 is done. Part 2, find the acute angle between K and P. So this is the plane and this is the line. There's intersection. So you can see here the normal and the direction vector of a line. We will use the dot product to find the angle. Since we need to find the acute angle, as I told you before, now it said that to find the acute angle between K and P, and if I see this correctly, then it is, since this is negative, so it could be possibly the possible value could be in here and in here. Since 180 must not be, since the angle must not exceed 180 degree, we will not use this. We will use this. We will accept this one. So first of all, finding the angle. The base angle first of all. So let's suppose if I take the base angle 1 upon root 6, then so the base angle is 66. Okay, base angle is 66 degree. Now I will find the angle. So it's going to be 180 minus 66. And so this is 114. This is the angle, or you could say the obtuse angle. And it has been asking for an acute angle. So we're going to again minus this to 180. 180 minus 114, and we will get the acute angle. So again, this is the acute angle. So 66 is the acute angle that we need to find. So we're going to use this. Since we need to find acute angle, we will calculate base angle removing the negative sign. You can also do that if you know the logic. So this is the angle that we need to find. Now doing part 3. This is the equation for finding the distance between a point and the equation of a line. This is the formula that you need to memorize. Okay, so yeah, ax plus by plus c minus e, the distance, and it is in modulus. You cannot have a negative output. You will always get a positive output, and down here is the magnitude, a square plus b square plus c square, and is equals to d. D is the distance between the point and the plane, the perpendicular distance from a point to the plane. So you're going to put the coordinates into the equations. Okay, and you get this, and there you go, you got the distance too right in front of you. This one is done. Moving on, another question. The point A and B have position vectors related to the origin O given by this. The line L passed through A and is parallel to OB. The point N is the foot of the perpendicular from B to L. This is what we are dealing with. This is the line L passed through A. It passes through A and it is to OB. So we can take OB as a direction vector since they both are going in the same direction. So OB is a direction vector, and we can take OA as a position vector. Then after that, the point N is the foot of the perpendicular from B to L. Foot of the perpendicular from B to L. So B, L, and the foot is N. We need to find the... Now it says state a vector equation for the line L. It is done. Find the position vector of N. Show that Bn is 3. So we need to find the distance. We need to find the distance. First we will find the direction vector of Bn. Then we'll take the magnitude of then we take the magnitude of it, and you will get 3. And also we need to find the position vector of N. Line pass through A, which means A is a positive vector, and position vector, and the line L is parallel to OB, so we have the direction vector of OB. Part 1 is done, and as for part 2, the point N is the foot of the perpendicular from B to L. Okay. And you got the equation of a line, you're putting in it. Okay. Now you will get the direction vector, then using the dot product. Okay, and then there you go, it's the same thing as before. So this one is done. Another question, the line M has equation this, the plane P has equation this. Show that the line M lies in the plane P. If the line is in the plane, we can prove since the direction vector of a line and normal of the plane is perpendicular. Okay, we can also use the dot product as well. We can also prove it by knowing that the position vector of a line lies in the plane, so putting the coordinates of the position vector in the equation of the plane. You can do it in both ways. Done, proved. Putting the position vectors, and it is also proved. Good. Now doing part 2. A second plane is perpendicular to the plane P, parallel to the line M, and contains a point with position vector 2, 1, 4. Find the equation of the plane, giving your answer in the form of ax plus by plus cz is equal to t, plane BK. Since plane P and plane K is perpendicular, so this is this. Since plane P and line M is parallel, you need to see this normal, okay? These are perpendicular to each other. If you look at plane K and line M is parallel, then look at the direction of these, also perpendicular. So that's why we can use the product rule, in which the direction in which the normal of plane K is perpendicular to both plane P and the normal of plane P and the direction vector of line M. So we can use a cross product to find the normal of NK. Okay. So we need to find this, and since this, yeah, it's okay, we can use the cross product. And let's suppose we have already find the cross product, and there you go, we have the equation of a curve. Of a plane, equation of a plane. Okay. And two lines N and M have equation this and this respectively. Show that the lines are skew, which means neither perpendicular nor parallel. Okay, not intersecting as well. Not perpendicular. Skew lines mean two lines not perpendicular, not parallel, and not intersecting to one another. Using that dot product, we can find whether it is perpendicular. No, not perpendicular. You can also see whether it is parallel. Different value of which means not parallel. We can also find if it is intersecting or not using the old-fashioned way, doing simultaneous solve and putting the values back into this. And no, it is not intersecting. Doesn't matter if it is minus sign, it does make a difference. Not intersecting. Okay, so we have this equation. The plane P has equation 2x minus 3y plus cz is equal to 16, and plane Q is this. The line M is parallel to the plane P and also parallel to Q. Given that M passes through the origin, find the vector equation for M. This is the plane, this is another plane parallel to the line M. We will use a cross product, and let's suppose I'm using it. 2 minus 3 6 multiply 1 minus 2 and 2. Doing all that cross product, everything, we will get 6 2 minus 1 as the direction vector of the line M. Then the equation would be like 0 0 0 as a position vector because it is passing through the origin, and 6 2 minus 1 is so this is the equation of a line M. Okay, this is the answer. Another question, the equation for the plane P is this and OS is this. The point N is it's the foot of the perpendicular from S to this plane. Find the position vector of N and show that the length of SN is 7. So it's the same thing as before. The normal of the plane is the same as the direction vector of line SN. Normal of the plane is the same as the direction vector of line SN. Of the line in the plane, and we will find the position vector of. Okay, so we have made the vector line of, so this normal was the same as a direction direction vector of line Sn. So this is how it is, and then OS we have taken the position vector. Okay, so this is a line, and now there's an intersection of the line and a plane, and we'll find the position vector of n. Putting this into the equation, and then we will find this, and back got this. Putting this back into this and this, and we have found the position vector On. Oh wait, oh yes, we have found a position vector On. Okay, and after finding On, we know we have used them. We have do the. I mean, we know how to find the magnitude of any vector. So the magnitude is 7, and so this is the answer. It's correct. So okay, so we have this last and final question, and then after that the 3D vector will be completed, and the whole O-level math P3 will be completed, and it will be at your own hands. Okay, so this is the last question. Two planes have equation this and this. The planes intersect in the straight line M. Okay, it intersect in the straight line. Find a vector equation for the line M. So as you can see here, the normal of this green plane and the normal of this blue plane, since they're intersecting and it forming a line, so if we take the cross product of these two normal, we will get the direction vector of the line M. Okay, so n1 multiplied by n2 is equals to direction vector of this. So we all know how to do the how to do the cross product, and let's suppose that you have done the cross product and your answer would be this is the correct answer, 6 minus 10 minus 7. Okay, now since we have this direction vector, but now one more thing is missing, which is position vector. How to find the position vector? So in order to find that, there is a little there is a special trick. You need to, okay, these are the two equations. Yeah, okay, so we will take any coordinate axis to 0, whether it is x is equal to 0, y is equal to 0, or z is equal to 0. Either one of these is correct, and then we're going to put it into the two equations. Okay, you can take any one of them and you will get the position vector. Okay, even though you will get a different position vector, but all three would be acceptable and correct. Okay, so let's suppose I just took x is equal to 0. I'm going to put this into the equation, this one and this one. So 0 plus 2y minus 2z is equals to 2, and 0 minus 3y plus cz is equals to 3. Now I will do simultaneous solve, and I will get the values, and the first value would be, if I do the simultaneous solve, then the first value would be y is equals to 3 and z is equals to 2. So we have this coordinates 0, 3 and 2. Okay, and now we're going to put this coordinate into the equation to check, in order to check that this coordinate is acceptable or not, whether it is correct or not. Okay, I mean, sorry, not in this one, in the original equation, this one and this one. Okay, so x plus 2y minus 2z is equals to 2. Now putting it, so 0 plus 2 multiplied by 3 minus 2 multiplied by 2 is equal to 2, and doing all the calculations, then it would be 2 is equal to 2, and it is proof it is correct. Now doing the second one, the same thing, 2x minus 3y plus 6z is equals to 3, putting the values into this equation. So it's going to be 2 multiplied by 0 minus 3 multiplied by 3 plus 6 multiplied by 2 is equals to 3. So 0, 9, 12 is equals to 3. Okay, and it's going to be 3 is equals to 3, which is also proved, which means this position vector is correct, and we got the equation of the line, which is 0, 3, 2 plus lambda 6 minus 10 minus 7. Okay, so this is the answer. And yeah, one more thing, it's not necessary for this to be a position vector. There are two more position vector that we could make it by by putting the value y is 0 to the equation, or putting the value z is 0 to the equation, then doing simultaneous solve, and then after getting the values and putting it into the equation to see whether it is correct or not. It will be correct. No, don't worry about it. You can apply any one from one of these three. So all the position vector is correct. If you put x equals 0, then you will get 0, 3, 2. If you put y is equal to 0, then you will get 9 upon 5, 0 and minus 1 upon 10. You can check it. It is correct also. And if you put z is equal to 0, then you will get 12 upon 7, 1 upon 7 and 0. All these three position vectors are correct. You can put any one of them and you will get the equation of the line. So I hope that you have understood each and everything, and yeah, you can ask me anything in the comment section below. And thank you so much for watching, and I hope I'll see you in the next course of software engineering. This was A-level math P3, but now I think I'm going to move on to A-level math S1 or M1, or maybe from a course similar, a course which is connected to, as anyone, if any one of you is doing software engineering, then you are in a right place, in the right channel, because I'm going to make courses similar to that. Okay, but other than that, I could teach chemistry, physics, maths, and computer science especially. So I hope you guys have enjoyed this, and thank you so much for watching this A level math P3